Hello guys and welcome to learning how to make your first game in Unreal Engine 5. In this free course, I will show you how to make a simple multiplayer prop hunt game that features a third-person soldier character, or the prop hunters, and the prop character that has the ability to morph or change into different props in the level. The game that we create in this free course will feature a prop character that can also spawn in fake props to throw off the prop hunters, and the hunters will have to find and eliminate the prop before the time runs out to win the game. I will show you how to make everything that you see here in this video from scratch, and I will explain it for beginners. I will show you step by step first how to modify the third-person character blueprint, how to import our custom soldier character, set up the animations, and add a simple weapon to our character. I'll show you how to give the hunter character the ability to shoot his rifle, and then we will create the prop character, which is just a simple character blueprint that we will add and give two different abilities. The first ability that we will add is its ability to morph into any prop that we drag into the level, and the second ability will be to spawn in fake props to trick the prop hunters. After we finish the prop character and its abilities, we will set up the prop hunt game mode that handles randomly selecting a player to spawn in as the prop character, while the rest of the players must hunt for the prop. We will also add a countdown timer that gives the hunters a certain amount of time to find the prop or the game ends, and everything that you see in this video will be included in this course. All the project files will be included for free in the description below. Now, if you guys do end up enjoying this free course, I've made the second half of this course that shows you how to add mobile input support as well as cross-platform multiplayer. So I'll actually show you how to add mobile touch input buttons, as well as how to set up a main menu, a host and join menu, and how to package this game for PC as well as Android devices. So we can either play as cross-platform, PC versus Android, or with other Android devices. So the second half of this course will only be available on my website, smartpoly.teachable.com, and it is completely optional to purchase this because I already show you how to make the full game, all of the gameplay mechanics in this free tutorial. However, if you do end up enjoying this free course and you do reach the end of this video and want to learn more, you can check out the second half of this course on my website, smartpoly.teachable.com, and learn how to add those mobile controls as well as additional things like the main menu, host and join game menu, and so much more. Like I mentioned, this will not be uploaded on the channel, so if you do want to support the free videos that I upload here, make sure you check them out, link in the description below. Also, if you want to dive more deeper into making games in Unreal Engine 5, I have an Ultimate Unreal Engine 5 multiplayer survival game course bundle. This course teaches you how to make a complete multiplayer survival game in Unreal Engine 5 from complete scratch. In this course, you will learn how to make things like a drag and drop inventory system, a complete crafting system where you can craft all sorts of different items, a harvesting system where you can chop down any tree, rock, or bush that you see on the map. We create 9 unique weapons and tools, things like a rocket launcher, pickaxe, hatchet, rifle, bow, and so much more. We create an entire building system where you can build your own bases using foundations, walls, ceilings, and you can upgrade your base from wood to then stone and then to metal. We add a raiding system where you can attack other players and raid their bases for loot. Then we create this open world map that has different biomes, procedural foliage, and each tree, rock, or bush that you see on this map can be harvested for resources. We add things like procedural AI, like this deer that you can hunt and harvest for resources. We also create these interactable structures, things like this refining forge where you can smelt iron ore. We have a crafting bench, storage box, and so much more. The course is also being remastered in the latest version of Unreal Engine 5.4, so both the original plus the remastered course will come in this bundle, which features things like controller input support and much more. Also, don't forget to drop a like on the video. Doing so is completely free, and you don't forget to subscribe because I am going to be uploading more free Unreal Engine 5 courses here on my channel, and you don't want to miss out on a future upload. So without further ado, let's get right into the free multiplayer prop hunt game course. Hello and welcome to the multiplayer prop hunt game course. I want to set some expectations for this course. So first and foremost, this is a beginner's course. However, I will not be showing how to download and install Unreal Engine 5, nor will I be showing / explaining the basic controls or user interface of the engine. I expect you, by the least, to have Unreal Engine 5 downloaded and installed, and at least have some basic knowledge of the controls and user interface. If you do not have Unreal Engine downloaded and installed, If you are not familiar with the interface, I do recommend you watch my complete beginner tutorial, as this shows you how to download and install Unreal Engine 5, and it explains in great depth the user interface for a complete beginner. The second thing is I will be showing how to create everything in Blueprint, which is Unreal Engine 5's visual scripting system. It allows anyone to make games in Unreal Engine without having to type a single line of code or without having to know how to write code. Now, I will not be explaining the basics of Blueprint in this video, but I will show you step by step everything that you need to do, as well as explain the basic logic behind the Blueprint code that we create. So if you are a complete beginner to blueprints, and if you have no idea what are blueprints, I suggest that you pause this video and go watch my Blueprint for Beginners tutorial, as this video will explain what are blueprints and everything that you'll need to know as a beginner. Now, with all of that out of the way, I can safely assume that you have Unreal Engine 5 installed. You at least have some basic knowledge of the user interface and controls, as well as some basic knowledge of Blueprint, so we can go ahead and begin with this course. So first off, we're going to go ahead and launch Unreal Engine 5.4.3. So go ahead and launch the engine. And now that we have this launched, we want to select the games template over here. And we're going to choose the third person template. And we can set our target platform to desktop and quality preset maximum. And we're going to go ahead and rename this project to our prop hunt game tutorial. So that's what I've named the project. I'm going to go ahead and click create. Now we'll go ahead and launch the project that we just created. So our first time inside of this project, if this is your very first time inside of the third person template, essentially this game template is a third person character that has the controls already set up. So if you head over here to the top, we have this green play button. Click on the green play button. This will play the game that the template has, which is this simple third-person character. You can use the WASD to move around. You move the camera around your character by moving your mouse around, and you can press the space bar to jump. So it has some very simple input and a very simple character controller that's set up. Now we're going to take this character controller and everything that's in this project, so the character blueprint, and we're going to modify it to create our prop hunt game. So essentially, to get started, we're going to organize our folders in our content browser. So to get to your content browser, you can actually open up the content drawer by clicking down here to open up the content drawer. And usually what I like to do is I like to click this dock in layout over here on the right. Now we'll go ahead and dock the content browser to always be shown down here at the bottom. And this is also very helpful for when we are importing assets and getting things organized in our project. The first thing that we're going to do is in our content folder, we're going to right click and create a new folder. And we're just going to name this to core. This will be like our core assets. And we can right click this folder and set a color to a red color. That way we know this is, where we're storing all of our assets for our game, and all of the code and everything will be inside of this folder. Now inside of that folder, we're going to double click and open this up. We're going to right click and create a new folder and name this to blueprints. So this will be our blueprints folder. So blueprints are where we're going to store all of our game logic, our code, everything that's used in the game will be inside of this folder. Now in this third person character game, we already have some blueprints already created for us. So we need to go ahead and move those blueprints into our blueprints folder. That way everything just stays organized. So we want to go over to the third person folder and over to the blueprints, and we should have this third person character blueprint, and we also have this third person game mode. What we're interested in right now is just the third person character blueprint, because this is the character that we are using here in the third person game. So this is the character that has all the movement set up and everything. So I'm going to take this blueprint class, I'm going to drag it and drop it on the core folder and click move here. So that should move it from the blueprints over to our core folder. Then we want to take that even further and move it into the blueprints folder. We should have our third person character blueprint inside of our core blueprints folder. So all of our main blueprints will store inside of here. So this is our main character blueprint. Now, if we go ahead and actually double click and open this up, I'm going to take this window up here. By dragging this window, we can dock this up here at the top. So we can switch between our third person map and our character blueprint. And also, what I like to do is I like to go to my editor preferences, and under here, under the appearance, down here in the middle, the asset open, editor open location, I like to set this to main window. But what that means is if I open something up like this, character blueprint, it will automatically dock this tab up here at the top. Anyways, now that we have this character blueprint open up, what we want to do is we want to replace this character mesh. So if you head over to the viewport tab in the character blueprint, you can see what our character blueprint consists of. So in our case, it consists of this character mesh. If you select on it, you can see that in this components, it's highlighted this mesh, this character mesh. So we want to replace this character mesh from the default character mesh with a soldier character mesh that we've downloaded from the Unreal Engine Marketplace. So that is our first task that we're going to go ahead and do. So to do that, we're going to go ahead and first open up the Epic Games Launcher, and we're going to go ahead and add a character mesh that we get from the Unreal Engine Marketplace. So if you never used the Unreal Engine Marketplace before, essentially this is a way that you can get different types of character meshes, assets, 3D models, animations, and use it for your game or Unreal Engine projects. There's lots of free assets on the Unreal Engine Marketplace that you can use, and we're only going to be using free assets. I only use free assets in my tutorials. That way people don't have to purchase or make additional purchases to follow my videos. And so to find the asset that we'll need, you want to go over here to this search bar to search products. And we want to search for military character and click enter. And we're going to, down here under the filter results, you want to click on free for the max price. So if you filter by free, it will show you automatically the free military characters or the ones that we're going to be using for this course. So up here we have this military character silver, which is the one that we'll be using. So go ahead and select on this military character silver. So you can see it's a very simple character mesh. And we want to add this to our game. So to add it, you want to click on this add to project. Now, if you haven't downloaded this before, it might say checkout. So if you haven't claimed this before, all you have to do is click on the checkout button, and that will go ahead and add it to your cart, checkout, and it will add it to your library. So after you do that, you then should see the add to project button. Now, after you see the add to project button, all you have to do is click on it, and it's going to show you select the project to add the asset to. Now, you might not see a project listed in the projects down here. So what you want to do is you want to click show all projects. You want to make sure that you hit that checkbox. And now you should see your project pop up. If not, you can search for it. So we can search prop hunt game. And so I have my prop hunt game tutorial right here. Now with this selected, you're going to see that we have this red message, asset not compatible with version 5.4. Please select closest alternative version. Essentially what this means is this military character hasn't been updated to Unreal Engine 5.4. And so we just need to select the most recent version of the engine that it's compatible with. All you have to do whenever you get this message is you don't have to stress. All you have to do is click on this little drop down and select the most recent version down here at the very bottom in this list. In our case, it's Unreal Engine 4.27. Now you can see we can add it to the project. That's all you have to do. Show all projects, select the project, and click and select the most compatible version. And then we can just click add a project. That will go ahead and download it and add it to our Unreal Engine game or project. So now that we've added that to our project, we should be able to go back into our prop hunt game project. And in our content browser, we should notice a new folder named military character silver. So if we go into that folder, we're going to notice a couple of folders and a couple of different assets inside of those folders. So just to go over these, we have first a female character. So if you double click and open this up, we have a female character right here. And then we also have a male soldier character. So this character is what we're going to be using for the duration of our course. So we want to go ahead and take this character mesh right here, and we want to use it in our third-person character blueprint. So go ahead and open up your blueprints, third-person character blueprint. And to change the mesh of our character, all we have to do is simply select on our character mesh right here. And over in the details will allow us to change certain properties about the specific component that we have selected in our blueprint. So in our case, we have the mesh, character mesh component selected. And in the details over here under the mesh, we can change things like the skeletal mesh asset. So if we hit this drop down, we should see a list of character meshes that we have inside of our project. So if we scroll up, we should see the MW underscore style one underscore male, or the male character mesh that we were looking at earlier. So if I select that, we should now see that character mesh be replaced with this soldier character mesh that we downloaded from the Unreal Engine Marketplace. Now, right off the bat, you're going to notice that obviously it looks funky. The character arms are all messed up. And so that has to do with the fact that we're using the same animation for this character that we're using on the other character. And so obviously you can see that they're incompatible because of the weird distortion on the arms. So we're going to not use the same animations. We're going to create our own animations for this character. So to go ahead and clear this, under the animation right over here on the details, we can just set the anim class over here to none. So then, now that we set it to none, we just need to compile. So we need to hit this compile button and click save. And that will go ahead and reset the character animations to none. So now we should see our character is in this T pose, and we can actually go ahead and play test this out. So all we've done thus far is swapped out the character mesh. So if we were to go ahead and go to our third person map and hit play, we can see that we have our simple character, or the soldier mesh, that we swapped out. We can actually jump and move around, and it has all the same input controls that are inside the third person character blueprint. Now, next up, what we want to do is we want to go ahead and give this character some animations, because obviously the character isn't running around or moving around. We just have a simple character in the T pose. So we're going to go ahead and start animating the character, bringing it to life by adding some animation. So to get some animations imported into our project, we first need to prepare our content folder. So go to your core folder and right click, and in here we want to create a new folder. So right click and create a new folder and name this to animations. And then just double click and open this up. And in here, we're going to right click and create a new folder for locomotion. So double click and open this up. And we're going to go ahead and drag and import some animations that I will provide. So you want to head to the lecture notes or the description of this video and download the project files that we'll be using. So what you should see is this project files folder. And if you double click and open this up, we have a animations folder. Inside of there, we have this locomotion folder. So inside the locomotion, we should have all 13 of these animations. And so we're going to select all of these animations and drag and drop them into the locomotion folder. And it's going to pop up with this FBX import options. Have you never seen this FBX import options window before? Essentially, when you try to import an animation, it's going to ask you which mesh you want to import the animations onto. So all you have to do is select the skeleton. So under the skeleton, we can hit this drop down, and we want to look for the character mesh that we're using. In our case, we're using this MW style 1 male skeleton. So this is the character, the military character that we're using. I want to select that. And now that we have that selected, we can go ahead and just click import all. That will go ahead and import all of those animations into our project. And now you should see we have all those animations. So now that we have those in here, we just want to do a file save all. That way we can save all of the animations inside of our project. So if we check out some of these animations, if you open up this jog forward, you'll see we have some jogging animations, some idle animations, a lot of different types of animations in here, and some different directions. So we have things like jog backward left, jog backward. So the character is moving in many different directions. So we're going to take all these animations and we're going to blend them together using a animation blend space. So let's go and do that right now. So if we head back to our animations folder, we're going to right click and create a animation. And down here, we want to select animation blend space. So let's go ahead and select that. So when you create an animation blend space, it will ask you to select or pick a skeleton. So in our case, we're going to pick the MW Style 1 male skeleton, the character skeleton that we're using for the duration of this course. So select that. Then we want to go ahead and name this blend space. I'm going to name this a blend space underscore locomotion. So now that we've created that asset, we can file, save all, and let's double click and open this up. Now, if this is your first time inside of the blend space window, what you'll notice is down here we have a preview right here in the center of our character. On the left, we have this asset details. Down here at the bottom, we have this graph or this grid. And down here on the bottom right, we have the asset browser. So the asset browser contains all of the animations in our project that are compatible with this character. So we have things like our idle, our jog, and what we can do with these animations is we can drag them onto this graph. And what the graph allows us to do is it allows us to blend between two or more animations. So the blend space allows us to blend different animations to essentially animate our character moving. So to go ahead and get started, the first thing that we'll need to do is we'll need to modify our grid down here. So right now, nothing is set up. We'll need to go ahead and set everything up. So to set up our grid or our graph, we need to modify the axis settings over here in the asset details. So over in the axis settings, we have a horizontal axis and a vertical axis. So the horizontal axis is down here and the vertical axis is right over here. So first, let's set up the horizontal axis. So if you expand this, we should see things like a name, min and max value, and a couple of other different settings. First thing that we need to modify is the name. So we want to change the name from none to direction. So that will be the direction that the character is moving. And we need to modify the minimum and a maximum axis value. So for our minimum direction, this will be -180, the value of -180. And for the maximum axis value, this will be +180. So when we modify these values on the horizontal axis, you should see down here at the bottom, at the direction, we can see the minimum axis value, which is -180, and the maximum axis value, which is +180. Now, we also want to change things like the grid division. So when I change this from 4 to 8, we should see more of these grid divisions right over here. And on each of these grid divisions, we can drag and drop animations onto these. So that will be helpful in a second. And lastly, I'm going to do wrap input. So this will just wrap the input to match the animations, and go ahead and save that. Now we want to set up the vertical axis. So expand the vertical axis. And down here, we're going to go ahead and name this vertical axis to speed. And we're going to change only the maximum axis value from 100 over to 800. Now, if we save that, we should see the vertical axis be updated. We have speed, starts at 0 and goes all the way to 800. Then we also want to change the grid divisions to 6. And let's also set this to wrap input. So save all of that. And now we should be able to start dragging animations inside of here and set up the blend space up. So the first thing that we'll do is we're going to search for our idle animation. We should only have this idle, regular idle animation down here. And to drag and drop this onto our grid, you can either select and drag and drop it like so. Now doing so will place it anywhere on the graph. And it won't be snapped to any of the grid locations. So we want to turn on snapping. So if we select and delete this, if we drag this animation and hold down Shift at the same time, you can see that we can now snap this animation to any point on the grid. So if you just hold down Shift while you drag this, it'll go ahead and enable that snapping. So in our case, we want to place this at 0, 0. So down here at the very bottom. And now we can see that this idle animation that we've dragged in is playing. Another thing I want to do is I want to click on the show sample names. That way we can see the name of the animation. So we want to go ahead and drag this again, hold down Shift and drag and drop it, and add this idle animation to each grid division down here at the bottom. So hold and drag our idle animation and click shift to snap it and drop it down here at each grid division on our graph down here. So we should have idle all the way down here, and we can go ahead and save that. Now the next animation that we want to add to our grid is our jog forward. So you want to search for jog underscore forward. So we should have this jog forward animation. So if we select this and shift select this and drag, we can snap it again. And we're going to snap it here in the middle. And actually what we want to do is we're going to change our grid divisions. So under our vertical axis, let's change our grid divisions up to 8. Then we want to check our jog forward and just shift and drag it up to snap this up here at our speed 300. So if you select that jog forward, we should be able to set the value of speed to 300 and the direction should be 0. So it should be down here. Now to preview our animations, you can hit Control and move your cursor around. And what you'll notice is we can blend between our idle animation, which is this character just standing here. If we hold Control and move this up, you can see we can place this green marker up here at our jog forward animation. So essentially what the blend space is doing is it's blending between 2 or more animations. In our case, this idle animation and our jog forward animation. So this will be handy because we can tell the blend space what animation to play depending on if the character is moving or if they are standing still. So now that we have our jog forward animation in here, we want to add some additional animations, things like our jog left, jog backwards, jog right, so that depending on where the character is moving, if they're moving backwards, forwards, left, or right, we'll play the proper animation. So we want to search for our jog forward left and drag our jog forward left to the left of our jog forward. Then we want to take our jog forward right, shift select and drop it to the right of our jog forward. So we should have our jog forward left and jog forward right. And again, if you hit Control and move your cursor around, you can see our jog forward left, jog forward right. You should see those different animations being played. So now that we've added those animations, again, we need to add some more different animations as well. So let's search for jog. We should see more animations. In our case, we just want to add our jog left and jog right animations. So first, let's select our jog left. Shift select that and drag and drop it on the left. We should have our jog left. And then we want to take our jog right and drag and drop it to the right over here. So just place it at the same positioning that I'm placing these points at, just like so. And then lastly, we want to add our jog backward animation. So select our jog backward, shift select and drop it on the grid on the adjacent ends. We should have our jog right and then jog backward, our jog left and jog backward. So now we should have our simple direction set up. So we should see all of the direction, jog forward, jog left, jog forward left, jog left, and jog backward. Now we just need to add our running animations. And for this, we're actually going to be using the same animations. And so this will follow the same exact setup, but with a different running animation. So for this, we're going to go ahead and add the same animations. So first things first, we're going to start with the middle. We're going to search for our run forward. And we want to shift and drag and drop this here on the center. Now what you're going to notice is if I take my little green marker and place it on the animation, this animation shows a character running off the screen. So we need to go ahead and actually modify that animation because as you can see, it's not properly set up. So if we double click and open up this run forward animation, I will go ahead and open up the animation asset. And inside this asset, over here on the details, we need to change a setting on here. So all we have to do is for root motion down here, we want to force root lock. So currently this animation has a root motion, which means the character is moving off the screen and they're not moving in place. So we just need to click this force root lock. That way they force the character to stay in place. So just save that and close out of there. And then let's go ahead and reopen up our blend space locomotion. So if we show the sample names, we should see our run forward now. and the character is staying in place. Now we actually want to shift and move this up to 600. So the value for this animation is it should be at direction 0 and speed 600. It should be up like that. And now that we have that placed there, we want to copy over the same animations that we have down here. So let's search for our jog. So we should have our jog forward left. So let's drag that over here on the left, and we have our jog forward right. Then we also want to get our jog left and drag in our jog right. So the same exact setup that we have down here. And then lastly, our jog backward and jog backward. So just save all of that. So that is our simple blend space added. These animations are set at speed 600, and they actually don't differ from the animations that we have down here, which the speed is set to 300. Now we can come in later on and change the value or the rates at which the animations play at the speed. That way it looks like our character is moving a lot slower. But essentially you would blend between, walking animations and running animations. That way the character can have walking animations or running animations. In our case, these are the same animations, so it won't have that difference. But we can add that as a feature later on. So we have our simple locomotion set up. So if you hit Control, you can see the blending between the different animations that we have set up in our blend space. Now, to actually go ahead and see this blend space work on our character, we need to create what is called an animation blueprint. So the animation blueprint will tie together our character blueprint to our blend space. So let's go ahead and create that right now. So head over to your content browser, and right next to your blend space, I'm going to right click and create a new animation. And you want to select this animation blueprint. So the animation blueprint, whenever we create it, it will ask us to select a skeleton. So we're going to choose the same skeleton that we chose for our locomotion, which is our MW Style 1 male skeleton. Just click Create. And now let's go ahead and name our animation blueprint. So we want to name this to ABP, Animation Blueprint _ character. For our animation blueprint character. Let's do a file, save all. And now we can go ahead and double click and open this up. Now, if this is your first time opening up the animation blueprint editor, essentially we have a viewport over here on the top left where we can preview our character and the animations playing on it. In here on the middle, we have this graph. So you can scroll in and out and use the right mouse button to pan around. We have actually two separate tabs. We have the anim graph and the event graph. You can toggle between both of those. Over here, we have details. And then down here at the bottom, we have this asset browser, which shows us animations that we have for this particular character. So the first thing that we'll need to do in here is in our anim graph, we have this output pose node. So to output an animation, we need to plug something into this result. So this little human icon pin, we need to plug in a new animation state into this result to output an animation. So we're going to right click here on the graph, and when you right click, you'll see this drop down of options pop open. And in here, we want to search for our state machine. We want to type in state machine, and we should be able to add a new animation state machine. So go ahead and select that, and we'll go ahead and add a new state machine node onto this graph. And what you'll notice is it has this little human pin, this animation pose pin. And if you actually drag off here, it'll create a little node or a little wire. You want to plug this wire into this result right here. So now that we've done that, we've hooked up our new state machine up to our output pose. And whenever we make any sort of change, whenever we plug in different values, we want to hit the compile and save buttons. Now, once we've hit compile, you'll see we'll get a little warning just saying that the entry node has not been connected to a state. And that's okay because we'll set this up here in a second. Let's go ahead and actually set this up. So to set up our state, we want to double click and open this up. And now we'll actually open up that state machine that we created. And whenever you're opening up these nodes, you'll notice here at the top, this is like the hierarchy. So we have the anim graph, that's where we were just at, and then the state machine, which is inside there. So inside of the state machine, you'll notice we have this entry with a single pin. And if you drag up there, it creates this arrow. And so if we drop it, we have a couple of different options. And for us, we want to create a new state. We want to add a state. So for the state, we'll rename this to our idle walk run state. So this will just be our simple idle walk run state. So now that we've created that, we can hit compile and save, and you can see that this warning message goes away. So in our idle walk run state, we can actually double click and open this up, and that will open up the state even further. And you can see that we have the signal node, which says output animation pose, and we have this little human pin. So this is the result. And so for this output pose, we want to plug in our animation blend space to this output. So to drag in our animation blend space, you just want to head over to the asset browser down here in the bottom right. And we have this blend space locomotion. So you can see this blend space that we just created is in our asset browser. So we can actually drag and drop this onto the graph. Now we'll add this green node or this green blend space node. So what you'll notice on this blend space is we have those two axes that we set up, the direction and the speed. And we also have this little human animation pose result, or this little pin. So we can first take the pin and plug that into the result. And if we hit compile and save, you'll notice that our character is now playing this animation blend space, and our character is playing this idle animation pose. And that is powered using this blend space node. So you can see that is powering and using that output and outputting that animation to our character mesh. So now all we have to do is we need to take these two values, the direction and speed. These determine what animations should be playing based on this blend space. So if I were to take any of the values, say if I were to change this speed value to 600, we need to compile. Now you're going to see that our character is playing that running animation. So based on the values that we determine in here, that will determine which animations should be playing on the blend space and what animation should be output. So let's go ahead and set this back to 0. Hit compile. And you see it's playing the idle animation. But essentially, we want to take these two values and we want to get our character's movement. And based on how fast the character is moving, we want to plug that speed value into here to power what animation should be playing. Thus, should the character be playing the idle animation if they're not moving, or should they be playing the running animation if they are sprinting? So the way that we'll do that is we're going to bind these values to variables that we can determine based on the character's movement, speed, and direction. So to bind these two variables, all we have to do is take off this direction pin, and it'll create a little wire, drop it on the graph, and we can promote this to a variable. Click on that. What that will do is if you click anywhere else on the graph, it adds this direction variable. And down here on the My Blueprint tab, we created this direction variable down here as well. So we want to do the same thing for our speed. So let's drag off here and drop it on the graph and click promote to variable. So if you click anywhere else, I'll go ahead and add the direction and speed. And I'll add these two different variable nodes. We can select and move around, and they are plugged into our direction and speed on our blend space. Let's hit the compile and save button. And all that is left to do is to bind these variables to our character's direction and speed based on our character blueprint. So the way that we'll bind that is through the event graph in the animation blueprint. So you'll notice we have this event graph over here. So if you head over to the event graph tab, this is where we can set up the blueprint logic for binding these variables, such as our direction and speed, to our character blueprint or the character's speed and direction. So in here, in the event graph, we have these two different nodes. So you can select them, and you can move around the event graph by using your right mouse button to pan around and zoom in and out using the scroll wheel. But in our case, what we want to do is off of this event, blueprint update animation, we have this little pin. We hover over it. It says execution. So off of here, we want to drag off of here, and it creates a little wire. We want to drop it on the graph and search for is valid. So if we type in is valid, we want to pick down here this is valid, the one with the question mark. We'll select that. Now we'll add this is valid node. So the very first thing that we want to do in an animation blueprint is we want to check and see if our pawn owner, so this try get pawn owner, are they a valid actor spawned in the level? So off of this try get pawn owner, this gives us a return value. We want to drag that into our input object. So compile and save. So essentially what we're doing is we're getting the owner of this animation blueprint. In our case, this will be the character blueprint. We're just checking to see if it's valid. Okay, does it exist? Okay, if it does exist, then we can go ahead and set our direction and speed. So the first value we want to set is our speed. So we'll take our speed variable and drop it on the graph. That will give us two different options. In our case, we want to set the value of speed. So we want to set speed. So let's hook this up for the is valid. So if our character is valid, we want to go ahead and set our speed. And to get our speed, we want to get it from our character based on a couple of variables. So off of this return value, we can drag off here and drop it on the graph. We want to search for the get velocity node. So off of our try get pawn owner, we're getting the velocity of our character. So that will return the velocity of our character, and it will return this yellow vector. We just need to convert this vector to a float, this green float value. So off of this return value, to convert that, we just need to drag and drop this and search for vector length. So we're just getting the vector length of our velocity, and that will return this green float variable, which is compatible. So we can drag in the return value and plug that in for the speed and compile and save that. So essentially all we're doing is we're getting the pawn owner, which is our character blueprint, checking to see if it exists, if it's valid. If so, we're getting the velocity of our character, converting that to a vector length and setting the variable of our speed to that vector length. The next thing that we'll need to do is set our direction. So we want to get our direction variable, drag and drop that on the graph, and we want to set the direction. So plug in the execution, and for our direction variable, we're going to get off of our try get pawn owner, drag off here and drop it on the graph. And for this, we'll need to do a little bit of calculation. So first, we'll need to get actor rotation. We want to use the get actor rotation node. And then we want to calculate the direction based on the rotation and the velocity. So if we drag off of this get actor rotation, we can search for calculate direction. We should have this calculate direction node. So it will have a velocity and base rotation. Just going to plug in the velocity and base rotation, and that will output the direction of our character. Then just plug in the output or the return value into our direction variable, and now compile and save that. So all we're doing is we're setting our speed and direction based on our character blueprint's speed and direction. So that's all that we need to do to bind our character blueprint to our animation blueprint. So now that we're setting these values based on our character's movement speed and direction, we're going to be using these variables in our state machine. Over here in our idle walk run state, we're using those variables in our blend space to determine what animation should we output based on our direction and our character speed. So now all we need to do is assign this animation blueprint inside of our character blueprint so we can see our character be properly animated. So let's go to our character blueprint, or our BP third person character. And if we head back over to the viewport and select our character mesh component, down here in the details, under the animation, we should be able to select our new animation blueprint that we just created. So under this anim class, we hit this drop down, we can search for our anim BP underscore character. So this anim blueprint that we created up here, we can select it down there. And now you can see that our character is playing this idle animation. So we can compile and save that. Now let's go ahead and go back to our level here and click play. And you see that our character is playing this idle animation. And if we run, playing these running animation, and you can see it's a little bit janky, or animations are a little bit buggy, but you can see that the character is playing a run animation. If we're moving, if I stop, we're playing the idle animation. So we'll just need to do a couple of different adjustments to fix the snapping of the animations there. But as you can see, it is using the animations blend space to blend between two different animations based on the character's movement speed and or direction. Now, next up, we're going to make a couple of different adjustments to our character. That way, the animations aren't playing as snappy and as glitchy as you can see here on the screen. So what we'll do is we're going to go into our blend space locomotion, double click and open that up. And in the asset details, you want to scroll all the way down so you see this sample smoothing down here. And down here under the weight speed, we're going to set this to a value of 10. And I'm going to check as well the setting, allow mesh space blending. And so this weight speed, this will allow for more smoother blending between two different animations. So if I save that and hit play, you'll see that we have a little less of snapping transition between the running and idle, but we still have a little bit of awkwardness when we try and move our character in any other direction. So we're also going to fix that by a setting in our character blueprint. So head over to your third person character blueprint. So in our character blueprint, you want to click on this class defaults. And over here in the details, you want to search for rotation. So if you type in rotation, we should have a couple of different settings that we want to change. And in here, down here at the very bottom, we should see this orient rotation to movement. We're going to uncheck that. So it should be set to false. And then down here under the pawn, we want to use control rotation yaw and check that to true. So we unchecked orientate rotation to movement, and we checked use controller rotation yaw. So we made those two different changes. Let's compile and save. Now let's head back to our game and hit play. And now what you'll notice is if I move my camera around, that will rotate the character based on where we're looking. So if I move my camera left or right, it will rotate the character left and right. And if I move, you can now see that we're using the directional animations based on the direction that our character is moving. So if I'm running left, we're playing the strafe left. I'm running right, playing the strafe right. And you can see that now we have our actual animation blend space working, and the directional animations are playing much smoother than before. So now that we have our basic character animations working, we set up our character properly animating, playing the proper animations. What we want to set up next is for this character is actually the soldier character that will need to be holding a weapon. So in our case, a rifle. So what we want to set up for this character is we want to give this character a rifle that they can hold in their hands. We also want to update the animation. That way the character has the proper animations for holding a rifle. And so we're going to go ahead and add a rifle mesh, as well as a couple of more different animations that we can blend with our basic locomotion animation. So you'll need to go ahead and download the project files. And in here, we should have under the animations another folder for rifle. So in your projects, you want to get it side by side. Go to your core animations. You want to right click and create a new folder in your project and name this to rifle. And double click, open that up. And then with the project files selected, you want to go into the rifle folder and just drag all of the animations inside of here. You should have a total of 6 and drop it into your animations rifle folder. So again, it's going to pop up with the FBX import options. So for our mesh, the skeleton, all we have to do is click this drop down and select the MW style 1 male skeleton and click import all. And that will go ahead and import all of the following animations. And then we just want to do a file save all. So all we've done here is we've imported these rifle animations. So to showcase this, if we look at, say, our rifle center, double click, open that up, you can see that Basically, we have this simple character that is holding a rifle. They have this holding rifle pose. So we're going to use this animation, or at least the upper part of this animation, and blend it with our locomotion that we currently have set up. That way our character can hold a rifle in their hand. So the way that we're going to set this up is we're actually going to create what's called a aim offset. So what an aim offset does is it allows the player to move the character's body or rotate the character's body based on where the character is looking. So if the player is looking up, the character's body will rotate up, or the mesh of the character's body, and it will show that the character or the player is looking up, or wherever the player is looking, the character's body will rotate to that position. So that is what the aim offset allows you to do. So to create an aim offset, you'll need the following animations. You'll need a center animation, a looking down animation, as well as a looking up animation. So we've created the center animation. You can see that we have this center animation, have this looking down animation, where basically the character is looking down, and then we have this looking up animation, which is called rifle up. So using these three animations, we can create a aim offset. And so we want to right click, and under the animation, we can create this aim offset asset. Okay. So select the aim offset. And whenever we create aim offset, it's going to ask us to pick a skeleton. That's our case. We want to pick the same skeleton that we've been using, which is our MW Style 1 male skeleton. And we're going to rename this to aim offset AO underscore rifle, and just save everything. Now, before we open up our aim offset, we need to actually prep the following animations. So we need to prep our rifle center, rifle down, and rifle up with a couple of different settings. So the way that we'll prep these animations is we're going to open up each of these individually. So first we're going to open up the rifle center. Let's actually make sure that we do a file save all. But inside of this rifle center animation, we need to set a couple of different settings inside of here. That way we can use this in our aim offset. So whenever you're creating an aim offset, what you'll need is you'll need the three animations, a center, a down, and up animation. But in addition, you'll need a static animation, which is just the sort of like the center animation that we have here. But all that it is a single frame. So you'll see this frame is just one animation frame, or a simple pose, a static pose of the character. So that's all you need for aim offset. You need center, down, and up animation, as well as a static pose. So if we open up the rifle center animation, in here we need to set the settings. So if you, under the asset details, scroll down, we need to set the additive settings. So down here we have this additive settings, and we're going to, under the additive anim type, we're going to change this from no additive to mesh space. Okay, so we want to select mesh space, and then it will pop open with another setting. It will ask us base pose type. We want to change this from skeleton reference pose. We want to change that to selected animation scaled. We should have selected animation scaled, and that will allow us to select an animation. So down here, we want to select the animation. So click this none, and we want to search for our rifle static. So that static animation pose that I mentioned before, we want to select that. And now we've added that setting down here. So essentially, we want to do this same exact thing for all of our aim offset animation. So our rifle center, our rifle down, and our rifle up. We'll do the same exact settings. So let's go to our rifle down animation, open that up. And same thing, under the additive settings, we want to change this from no additive to mesh space. We want to change this to selected animation scaled. And then we want to select and search for our rifle static animation and set it like so. Save that, close out of there. Same thing for our rifle up, double click, open that up. We want to go ahead and go to our additive settings, change this from no additive to mesh space, change this to selected animation scaled, and select this none and change that to rifle static. So we've done that, and save that and close out of there. And we've done all the following changes to our rifle center, rifle down, and rifle up. So now that we've prepped these animations, we can now use them in our aim offset. So let's go ahead and double click and open up our aim offset rifle. And what you'll notice, the aim offset is that it looks very similar to our animation blend space. Okay, it looks very similar in which you have a viewport here in the center, have your graph, and you also have something like the asset detail. Now in our aim offset rifle, in here we just need to set one of our graph axes. So in our axis settings, we're only going to set up the vertical axis. So expand the vertical axis. So in here, we're going to give it a name. So we're going to name this to pitch. And the minimum value will be -90. And the maximum value will be +90. And then just save that. So all we're setting is this vertical axis. That's all we're going to need. And then in the asset browser, we want to search for our rifle underscore. So we should have the following animations: our rifle center, rifle down, and rifle up. So we're going to take our rifle center, shift and drag and drop that here in the middle. And if we click on this show sample names, that will show us the name. So we have our rifle center. Then we'll take our rifle down and plug this down here at the bottom. And then shift select and take our rifle up and plug that up here at the top. So now if you hit Control, you can move your cursor around, or the green marker, to preview what the aim offset will look like. So essentially, if our character is looking up, it will move the character's mesh or the body to look up. The character is looking down, it will move the character's body to look down. Okay? So depending on where the character is looking, it will rotate the character's body to wherever they're looking. That's all that an aim offset allows you to do. It allows you to blend between the poses of a character based on where the player is looking. So now that we've created this aim offset, we can go ahead and actually add it in our animation blueprint. So the same thing, to actually use this aim offset, we need to use it inside of our animation blueprint. That way we can bind things like the pitch, wherever the character is looking, to drive where or what animation should be playing. Let's close out of there and let's go to our animation blueprint. And inside of the animation blueprint, you want to head over to your anim graph, double click the state machine, open up our idle walk run state. And in here, currently we have our blend space. So we have our animation blend space and then the output animation pose. So what we want to do is we want to modify this so that we can use not only our blend space, we only want to use the blend space for the lower half animations, things like our walking and running, but we also want to use our upper body aim offset animations to blend with our lower body locomotion animation. So the way that we're going to blend those two animations together is we're going to use the node called the layered blend per bone node. So if you right click here on the graph, you can search for the layered blend per bone. So we have this layered blend per bone node. Go ahead and select that. So what you'll notice is on this node, we have a base pose, a blend pose, and then an output. So all this does is it takes two different poses, blends them together, and it returns the outputted blended final pose. So what we'll do is we'll hold on Alt on your keyboard and disconnect the pin by clicking. So if you hold on Alt and click, that will go ahead and break that pin. We want to hook up the locomotion to our base, then the animation output to our output animation pose. And if we select and move these down, compile and save that, we need to hook up our other animation that we're going to blend this with. So in our case, we need to drag and drop our aim offset. So in the asset browser, search for your aim offset, AO underscore rifle. Drag and drop that on the graph, and that will provide us with our aim offset. So this aim offset, we have this animation pose, so we'll plug that into our blend pose, compile and save. And currently you're not going to see anything actually update or change. That's because we need to plug in a couple of values into our aim offset. So the first thing that we'll do is we need to actually create a value for our pitch. Just like we've promoted these variables, we need to do the same exact thing. So for our pitch, we're going to take this and drop it on the graph and promote this to a variable. So compile and save that. So the pitch will control essentially where the character is looking, and we'll need to bind that to the variable from our character blueprint. But we also need to plug in this base pose. So in our asset browser, we want to search for our rifle static, and we have this rifle static animation. So I'm going to take this rifle static animation, drop it on the graph, select this, and plug this into our base pose like so, and compile and save that. Now, currently, we're still not seeing any changes, and that is because we need to set up this layered blend per bone. Okay, because right now we're taking this locomotion and this aim offset, we're blending them together, but we need to determine where exactly should we blend these two animations, at what point or at which bone in the character's body should we blend it. So in our case, we want to select this layered blend per bone node, and over here in the details, this will allow us to set up this node. So under the config, we have this layer set up. So if you expand that, you have this index, expand that again, and add a branch filter. So if we click on this add element or the plus icon, I will add a index, expand that, and you can see now we have a bone name and a blend depth. So essentially, we just need to specify the bone name of where we will blend or create the blending of the two animations. So in our case, we want to pick a bone that is here in the center because we want to blend the lower half locomotion with the upper half aim offset. So I'm going to, under the bone name, rename this to spine underscore 01. You want to make sure that you use the same exact capitalization that I use in here. And these are just based on the character's bones in the body. And then I want to set a blend depth at least 1. So now that we've made those changes, we can compile and save. And now what you're going to notice is we're now blending those two animations. Now we also want to click on Mesh Space Rotation Blend. You want to click on the checkbox, compile and save. And now what you should see is we're blending the lower half locomotion with the upper half aim offset. So we have the aim offset rifle playing out the upper half of the body, and the lower half is the locomotion. And using that layered blend per bone, now putting the blended animation result. Now, all that is left to do is we need to bind this pitch variable to wherever the player is looking. So if the player is looking up, we need to bind that the pitch variable. That way we can tell this aim offset which animation should be playing. Should the character be looking up or down or whatnot? So the way that we'll do that is in the event graph, the same exact way that we've bound our other variables. We're going to do that in the event graph as well. So to set our pitch variable, we'll need to do a little bit of calculation based on where the character is looking or the rotation of the character. So off of this try get pawn owner, this will get our character. Off of here, we want to drag and search for the get base aim rotation node. We have this get base aim rotation. So select that and drag that over here. And we're going to right click this return value, and we're going to select the split struct pin. So that will output the X, Y, and Z, or the roll, pitch, and yaw. In our case, we're only going to be using the pitch. We set our pitch variable. And so off of our pitch, we're going to do a check. Actually, drag off of the pitch and search for the greater than or equal to. So we're going to check and see if the pitch is greater than or equal to. And so we'll select that. And the value that we want to check and see is if it's greater than or equal to 180. And then off of there, that will return a red true or false variable. So off of here, we can do a branch. The branch will return whether that is true or false. So first hook up the execution. So if the pitch is greater than or equal to 180, we want to set our pitch. So get our pitch and set that. So first we'll set up true. So if it is greater than or equal to 180, we'll set that to our pitch, like so. So if it is greater than or equal to 180, we're going to get our pitch and subtract that. Do a operator subtract. Subtract our pitch by 360 degrees. So plug that in for the pitch. However, if it is false, we want to set our pitch, set that to our output right here. So plug in the pitch into the set pitch node. So essentially all we're doing is we're checking to see if the pitch is greater than or equal to 180. If it is, we're getting the pitch. Subtract that by 360. Set that so. If not, we're just setting the pitch value like so. So compile and save. That's all we're doing for setting our aim offset. So we're basically getting the character aim rotation and setting the pitch value based on wherever the character is looking. And now that pitch value will be used in our state machine over here in our aim offset. It will be used to determine what animation should be played or where the character should be rotated based on wherever the character is looking. So now we should actually be able to test this out. So if we head back to our third person map and hit play, if I look down, the character is looking down. If I look up, the character is rotated up. So to showcase this even more, I can actually close my content browser and hit play. So now you can see the character looks up, the body is rotated up, the character looks down, the body is rotated down. And you can see when I move around as well, the character is blending the lower half locomotion animations with the upper half aim offset animations. So we're having that blending between those two different animations. So now all that is left to do is we need to add a rifle that the character can hold in their hand. Because right now you can see that our character has the rifle animation being played, but we don't have anything actually held in our character's hand. So we're going to go ahead and add a rifle mesh, download a rifle mesh from the Unreal Engine Marketplace. So go ahead and open up the Epic Games launcher again and head over to the Marketplace. And in the Marketplace tab, we want to go to the search products and search for military weapon. Search for military weapon. And again, you want to filter this by free. And that will pop open and filter this by free assets. So as you can see here, we have military weapons silver and military weapons dark. So in our case, we're going to choose the military weapon silver. So select that, and we can go ahead and add this to project. So once you've checked it out and added it to your library, you can now add it to a project. Again, you want to click show all projects so we can show all of the projects that we have. We want to search for our prop hunt game tutorial. Select it. It's going to say asset not compatible. Again, you just want to hit this drop down and select the most recent compatible version, which is 4.27, and then click add to project. So that will go ahead and download the asset and add it to our project. And now in our project, you should see in our content browser a new folder named military weapon silver. So inside of here, we have a folder for weapons. We double click, open that up. You can see we have a variety of different weapon models that we can use for our game. So in our case, you want to use this assault rifle weapon over here for our character. So I'm going to go ahead and add that to our character. So the way that we'll add and attach this to our character is using sockets. So sockets are the way that you attach weapons or items or armor to your character by using sockets. So the way that we'll add the socket is we'll need to go to our character mesh. So to find our character mesh, you want to go to your military character silver. And we're going to open up this skeleton, the MW Style 1 male skeleton. So open up the skeleton, and this will show us the character mesh that we have and also the different bones in the character mesh. Over here on the left, you should see all the different bones listed in the character's body. So we have things like the spine, the hand, the clavicle, all the different bones in the character's body. So depending on the different bone that I select, you can see it highlighted over here on the screen. Now in our case, we want to add a socket to our character's hand bone. So go down over here and we want to search for the hand R. So once you found the hand R bone, the one over here, we want to right click onto that bone and we have this little menu that will pop up. We want to click this add socket. So that will go ahead and add a new socket onto that hand bone, which we can then use to attach different types of weapons or items to the character's hand. So we want to go ahead and double click this socket to rename it. So select that and rename this to rifle socket. Now, whenever you rename the socket like so, you want to take note of the capitalization, the punctuation, the exact naming of this, because this is very important that you use the exact name later on. So save that. Now that we've added that socket, we can actually attach something to this character. If you select the socket, you can right click and we should have this add preview asset. So now that we have this add preview asset, we can add an actual asset to that socket. So we're going to add this assault rifle socket. And now that we have it selected, you can see that in our viewport, I put my mouse inside of here, I can move around. We have that rifle socket. Now, one thing that I want to do is I actually want to adjust the camera speed in here. So over here on the camera speed, you can adjust that so you don't move around as fast. But you want to select this rifle socket. And now we can actually move and rotate this rifle around and position it where we want it to be on the character. Now, first things first, we actually want to preview the rifle animation on this character. So up here at the top, we can preview a particular animation on the character. So if you click this preview animation, we can search for our rifle. And we want to search for our rifle center. So if we select our rifle center, now you can see our character is playing that preview animation. And we can actually take this little player and pause it by clicking pause or by just selecting it like so. But now we should be able to select this rifle socket and actually rotate it and move it around. The first thing that I'm going to do is I'm going to change this gizmo to world space. So if you change it to world space, it will show the globe there. And then if I press E, I can rotate it and take these little gizmos and rotate it like so. And if I press W, I can move it around. And again, let's just try and position this the best that we can. And rotate this and something like that and rotate it down. And if you don't like the snapping, you can turn off the grid snapping. So you just click on that little icon that will turn off the snapping. And that will give you more of a precise rotation. And also with our movement, we can turn off our movement snapping as well. That will give us, again, more precise placement over that. Let's just move and rotate this around and make sure that the character is holding the weapon in their hands. Okay, so something like this. So once you've got it in roughly the best position that you want, save that and actually close out of there. And now you want to head over to the character blueprint, our third person character. And in here, we're going to add that rifle mesh. So we're going to head over to the viewport, and under the components, we're going to add a new skeletal mesh component. So select the skeletal mesh component, and we can rename this to our rifle mesh. Now with that skeletal mesh component selected, in the details, we can set the mesh. So under the mesh, we can set this to our assault rifle A. And now you can see we've added that assault rifle mesh. And in here, what we want to do is drag this rifle mesh onto our character mesh. And now you can see that we have our character mesh here, and then underneath it, we have the rifle mesh. So essentially what that is doing is we're parenting the rifle mesh to the character mesh. We're sort of attaching it. Now with this rifle mesh component selected, over here in the details, we need to specify what socket this is attached to. So under the sockets, we have the parent socket. We can click on this little browse icon, and we can select the rifle socket that we created. So now that we have that added, you're going to see that it's up here floating off in the distance. All we need to do to get it positioned properly is to reset the location and rotation. So we click on these little back arrows that will reset the rotation and location, and it will properly place it to where we have it positioned based on where we set up the socket location. So compile and save that. And now we've added a weapon to the character's hand. So if we go back to our viewport and hit play, you can see that we now have a rifle in our character's hand. And so next up, what we should focus on is let's actually rotate the camera or position it so that the camera will be right over the character's shoulders, and we can get sort of a camera offset. So let's go ahead and work on that now. So if we go back to our third person character blueprint, what you'll notice in the viewport is we have this camera component, and we want to go ahead and modify the camera positioning. So the way that we'll do that is we have this camera boom. The camera boom is sort of like the arm that attaches the camera to the character. So you can see we have this red line. So essentially that is what attaches the camera to the character itself. So if you select the camera boom over here in the settings, we can change things like the arm length of that camera boom. I'm going to set this to 300. That will bring the camera closer to the player. And we can also set things like the socket offset. So I'm going to input some values inside of this offset, and you can just copy the same values that I've done, or you can add your own offset and play around with the values. I've just found that these values work for me. So I'm going to enter 96.8, and then I'm going to enter 62.6. So I've added a little bit of offset, and also I'm going to modify the location as well. For the location, I'm going to change this to 12.9. For the X, for the Y, this will be 12. For the Z, this will be 58. And so I modified the location as well as the arm length and the socket offset. So compile and save that. And now we should have the camera positioned up like so, and is also offsetted. So it's not directly behind the character, but rather looking over the shoulder of the character. Now if I hit play, you can see that we have this camera sort of position looking over the character, and we can actually see the rifle in the player's hand. Okay, so we modified the camera position, and now we can actually see sort of where the character is looking from the character's perspective. Now, the next thing that we'll do is we need to go ahead and start setting up our rifle logic. So essentially, we want to give our character the ability to fire the rifle, because in this prop hunt game, we want to essentially be able to find the prop. Whenever we do find the prop, we want to be able to fire our rifle to deal some damage to the prop. So we're going to give the character the ability to fire the rifle by clicking the left mouse button or holding it down. Now we'll go ahead and fire the rifle, fire a shot or a line trace, and depending on if we actually hit the prop, we'll go ahead and deal some damage to that character. So the way that we're going to set up the logic for our rifle is in our character blueprint. So let's go ahead and open up our content browser and dock this in layout. So you want to go ahead and open up your character third-person character blueprint. And the way that we'll set up all of our logic, all the blueprint logic is over in the event graph. So if you head over to the event graph, you're going to notice that we already have some nodes or logic set up in this event graph. You'll see things like our camera input, our movement input, and jump. So these are just the basic controls that our character already has set up. Things like our movement input and jumping. That's all set up using these blueprint nodes. So in our case, what we want to set up is we want to set up a simple firing logic. But we'll need to add a new input for shooting. So just like we have an input for jump, we want to add a new input for firing or shooting our rifle. So to add a new input, we need to go ahead and add a new input action. So whenever you're adding inputs to your character, you're going to add it inside of the content browser. So head over to your content browser, and we already have some inputs that are set up when we've created this third-person template. So the third-person character template already has some inputs set up in this project. So to find those inputs, you want to go to the third-person folder and input, and you can see that we have in this input, we have this IMC. So this is the input mapping, and then in the actions folder, we have the input actions. So we have things like our input action jump, input action look, and our input action move. Now we're going to actually take these input actions and move it into our core folder. So go back to your third person and take this input folder and just drag and drop it into your core folder and click move here. So now in our core folder, we should have that folder for input. And so now that we have that input folder moved here, we can go ahead and double click this up and open up the actions. And in our input actions, we can add a brand new input action for our shoot. So right click, and to add a new input, we can just right click and under the input down here, add a new input action. So select that, And we'll go ahead and rename this to input action underscore shoot, or input action shoot, and file save all. And so we've added our input action shoot. What we need to do next is we need to tell the game what key should this input action be bound to. Okay, we need to tell the game essentially that the left mouse button is bound to the shoot input action. So the way that we'll tell that binding is you go to your input folder, we have this input mapping context. So this input mapping context holds the bindings for the input actions. So it tells us basically what input actions are bound to which keys on the keyboard. So if you double click and open up this input mapping context, and inside of here, you'll see a mappings. So if you expand this, this will show the input actions that we currently have set up. And if you expand those input actions, you'll see the following keys that are associated and bound to those input actions. So for example, our input action jump is bound to our spacebar key. Our input action move is bound to our WASD keys, or our up, down, left, and right arrows. Then our input action look is bound to our mouse X or Y axis. So wherever we're moving our mouse is wherever the character will be looking. So those are our different mappings. So if we unexpand those, essentially we want to add our new mapping for our input action shoot. So click on this little plus icon to add a new input mapping. And if we click this, we can assign our input action shoot. So now we have added our input action shoot. And if we expand that, we need to add a key to map our shoot button to. So if you click this little drop down, we can search for our left mouse button. So now we have this left mouse button. We can assign it like so. Now we've bound our input action shoot to our left mouse button. So it's as simple as that. Now, if you were to support things like controller or add multiple support for other different types of input, you could add an additional mapping or binding for other different types of input. But in our case, we're just going to keep it simple and only set up the keyboard and mouse. So save that. We've added that input mapping. We can close out of there. And now if we head back to our third-person character blueprint, we should be able to right-click and search for our input action underscore shoot. So now we have the input action shoot. We want to add our input action shoot event. So this one right here. So if you add it, you're going to notice that we now have this red input action node, just like what we see up here for our jump input action. So now we have one for our input action shoot. So if we hit this little drop down arrow, that will expand it all the way. So we can see we have a triggered, started, ongoing, completed, and canceled. And so in our case, we want to use the started and the completed the same way that we have the jump set up. Basically, if we're holding down the shoot, that will call the started. And if we stop holding down the shoot button, we'll call the completed. Okay. So we want to create two different events, one for starting our shoot logic and one for ending our shoot logic. So on here on the graph, we want to right click and we're going to search for add custom event. So we're going to add a custom event, select that, and we're going to rename this custom event to start fire on server. So our start fire on server logic. And we're going to select this event. And since we're making this game multiplayer, we're going to need to set everything up for multiplayer. So if you're setting up a multiplayer game, you want to make sure that you set up all your events, all of your blueprint logic to be able to be replicated and designed for a multiplayer game, because there are certain rules and certain things that you need to abide by in order to create multiplayer games inside of Unreal Engine. And so this fire on server event needs to be set to run on the server. And so the way that we'll do that is we'll select this event, and in the details, we can set this to run on the server. Now, if you're a complete beginner with multiplayer, a lot of this will be completely new to you. This will be new concepts for you, but just hang on and follow exactly what I do in this tutorial. So we want to set this to run on server. So you want to select this event, and in the details, under this replicate, we want to click run on server and compile it and save that. And now that we've created this event, we can call it when we click our shoot button. So under the started, we can drag off here and call that start fire on server. And we'll call that start fire on server event. So essentially when I click the left mouse button, that will call our start fire on server, which is this event over here. Now for this event, since we're firing a rifle, we want to essentially call some logic that will fire over and over and over to create sort of a automatic rifle firing logic. So essentially we'll need to have some sort of function or event that will be called over and over and over on either a tick or a timer. So the way that we'll do that is we're going to be using a timer that will fire off every 0.1 seconds. So off of this start fire on server, we're going to search for set timer by event. So we have this set timer by event. We'll select that node, and that will allow us to specify events that will get fired off based on a time or duration that we specify, and we can set that to looping. So we'll loop over and over and over. So for our event, we need to drag off here and add a event. So drag and drop it and search for add custom event. And we need to rename this to our fire rifle. So compile and save that. Then for our duration, we need to set a time. So we're going to set this to 0.1 seconds. And we're going to set that to looping. So every 0.1 seconds, this fire event will be called. It'll just called over and over and over as long as we're holding down our left mouse button. So this is perfect for some sort of shooting logic, because this will just fire over and over and over, like if we were firing an automatic rifle. Now also, we want to take this timer. So this timer gives us a return value or a reference to the timer. We want to take that return value and promote this to a variable. So that will add a new variable down here, and it will save sort of a reference to that timer. That way we can pause the timer or stop the timer if we need to. So down here in the variables, we want to rename this to our fire timer. That is a fire timer. So compile and save that, and we're just saving a reference to this timer. Now what we can do is we want to add an event to stop the timer. So up here at the top, we can right click and add custom event. And this will be called stop fire on server. So this will stop the fire, this will start the fire. So up here on the stop fire on server, we want to again set this to a run on server. So up here in the details, change this from not replicated to run on server, and compile and save that. Now to stop this timer from being fired off, we want to get our fire timer and get that on the graph and call our clear and invalidate timer by handle. So essentially that is sort of stopping the timer. So select that node and plug that in like so, and compile and save. Now we can just call this stop fire on server when we let go of the left mouse button. So off of this completed. So off the completed, we can call that stop fire on server. So if we unexpand this, we can collapse that like so. So when we call our input action shoot, if we hold down the left mouse button, that will call our start fire on server, which will start this timer. So every 0.1 seconds, we'll call this fire rifle event. And just to see everything working in action, we can drag off here and add a print string, development print string, and we can print off a hello. Now, if we let go of the left mouse button, that will call this stop fire on server, which will stop this timer, and it should stop printing this hello. Let's compile and save this, and we should actually be able to test this logic out. So we go into our game and hit play. If I hold down my left mouse button, you can see that we're calling that hello. If I let go, it will stop printing that out. So as long as I hold down the left mouse button, it's firing that event, fire rifle event. It's calling and printing that hello to our screen. So this is exactly the logic that we need for our firing rifle. So So as long as I'm holding down the left mouse button, it will call the firing rifle logic. And if I let go of it, it will stop firing our rifle. So now that we have this basic logic set up, we need to set up the fire rifle event right over here. So essentially, when we fire our rifle, we'll need to do a bit of a calculation. We'll need to shoot a line trace from wherever the character is looking, and we need to go ahead and see if we actually hit anything. So the way that we'll do that is we'll need to do a little bit of calculation, and we'll need to pass some values from the character to the server. So since this is a multiplayer game, we'll have to set everything up to ensure that everything is replicated and is set up for multiplayer. So down here under our fire rifle, we're going to right click and add another event, add custom event, and we'll rename this to get client camera rotation. So we'll need to get the client's camera rotation, basically where the character is looking on the client, and pass that to the server to do some calculation on the server. So we'll need to select this event. We want to change the details, replicates. We want to set this to run on owning client. So this will run on the client. So the reason why we're doing this on the client is we need to get the client's camera rotation, because that type of information is only stored on the client, rotation of the camera. And we want to pass that value to the server where we can do the calculation for our line trace. So off of our fire rifle event, we can delete this print string and now call our get client camera rotation and compile save. So now we're calling this event down here. And so now this event, what we want to do is we need to get our camera. So we're going to get our follow camera, which is our camera component, get that on the graph, and off of there we want to get the world rotation. Call the node get world rotation, and we're getting the rotation of our camera, and that will return the value. And then we want to call another event on the server so we can pass this variable, this value, to the server. So right below it, we're going to right click and add custom event and rename this to line trace on server. And select this event and set this to run on server. And also we'll need to add an input to pass this value over. So under the inputs, we can click this plus icon, and that will allow us to input a variable that we can pass from the client to the server. So under the inputs, we want to change this to this rotator input. So change this variable from a Boolean to a rotator and rename this input to rotation. So compile and save that. And now off of this get client camera rotation, we can call that event line trace on server. So now we can plug in the return value to the rotation. And now what we're doing is we're getting the camera rotation on the client, and we're passing that value to the server by calling this event. And now on the server, we have access to that rotation value. Now, the last thing that we'll do is we're going to create a function that will store the logic for our line trace. So if you never used functions before, essentially a function is sort of like a collapsed graph of Blueprint nodes. So to create a new function over here on the My Blueprint tab, we have functions. We can click on this plus icon to create a new function. And for this function, I'm going to name this F for function rifle line trace. So our function rifle line trace. So this function will need to have one input for our rotation. So if you select this function node, under the inputs, we can click on this plus icon, and that will add a rotator input. Or if you don't have the rotator input, you can change this to the rotator input and rename this input to rotation. So compile and save. And to get back to our event graph, we can go back to our event graph by clicking the tab over here, and we can call that function that we created. So if you, under the functions, drag that function onto the graph, you can call that function, hook up the execution, and also hook up the rotation. Now to recap, what we're doing is when we're calling that fire rifle event, we're calling this get client camera rotation. So it's getting the rotation of our camera on the client. We're passing that to the server. And then we're calling this function. We're passing that value of the rotation to the function itself. So if we double click this function, that will open the function up. And inside of this function, this is where we're going to do the line trace logic. So inside of here, we're going to right click and search for the line trace by channel. So we have this align trace by channel node. Let's select that. So this align trace by channel will fire off a line trace to check and see if we actually hit anything on our screen. So this is very common in shooter games where you're trying to shoot and see if you hit an object. Often in first-person shooter games, you're going to be using the line trace by channel node to see if you actually hit anything on your screen. So first things first, let's hook up the execution. So the execution like so. So for our line trace by channel node, we need to specify a start and end location. So basically, we're going to do a little bit of calculation to determine where we should fire off our line trace. And where we're going to fire it off is based on the character's camera position. So we're going to take our camera, or our follow camera, and get that on the graph. And then we're going to drag up there and get the world location, get world location of that camera, and take that and plug that in for the start location. Then for the end location, we're going to do a little bit of math to calculate essentially where we should do the end of our line trace. So off of our rotation, we're going to drag off here and get forward vector. We're going to get the forward vector of our rotation, and that will return a vector or this yellow value. And then based on that, we're going to multiply this to a multiply. We have a operator multiply. We're going to multiply this by a float. So down here in our variables, we're going to add a new variable and rename this to bullet distance. And so this will determine how far our bullet should fire, or how far our line trace should fire off. And we want to change this bullet distance variable from a Boolean to a float and compile and save that. So now that we've compiled the variable, we can set the default value of this distance, so of the bullet distance. And we're going to set this to something like 10,000. So that will be how far our line trace can go. Then take this bullet distance variable and get that on the graph and plug that in for our multiply. So we're multiplying the rotation forward vector by our bullet distance. And then we're going to take our return value and add to a add operator, add our start location with our bullet distance multiplied by our forward vector, and that will essentially give us our end location. So essentially, we're calculating our start and end position for our line trace, and now we should be able to actually see this in action. Now, some other couple of settings that we need to change. We need to change this from trace visibility. We want to change this to camera since we're doing this trace from the camera position. We also want to trace complex. That way we can actually hit the character mesh. And then we're going to draw a debug. So under this draw debug type, we want to set this for duration. That way we can actually see the line trace that we're doing. So compile and save that. And now we should be able to see this happening in action. So I go ahead and hit play. I can left mouse button. You can see that we're firing off this line trace every 0.1 seconds, as long as I hold down the left mouse button. So if I stop holding down the left mouse button, we're not firing the line trace anymore. If I start holding it down, we're firing the line trace. Now this is happening exactly where the camera is looking, or the center of the camera position. So basically, let's say that's the center of our camera. It's going to fire a trace directly in the center. So later on, we're going to add things like a crosshair in the center of the screen. But basically, the line trace is firing off from the center of the camera's position. And this little red box is where the line trace hits. Okay, so if we hit something, you'll see that red box. So currently we're hitting the ground. If I fire it off into the sky, you can see that we're not actually hitting anything, but if I fire it down into the ground, you can see that we're actually hitting this wall right here. So that is our basic line trace logic for our firing rifle. Now what we want to set up next is, other than the line trace, the character doesn't really know if they're firing the rifle because there's no sound, there's no animation that's being played. So what we want to set up next is we want to set up some sound and some particle effects to show that the player is actually firing the rifle. So let's go ahead and set that up now. So in our content browser, let's go ahead and open this up and dock this in the layout. If we go to our military weapon silver, weapons, we should have a folder called animations. So if we double click and open that up, we have some animations for our rifle. So we have this fire rifle _W. If you open this up, you're going to see that we have this fire rifle animation. And so if we move this animation or play the animation, you can see that we're firing off this particle effect. Yeah, this particle effect that's playing, as well as a fire sound. So this is already set up for us, the animation itself. And they're using these muzzle flash and fire cue sound to play not only the particle effect, but the sound as well. So this is already set up for us. So all we need to do is play this animation whenever we fire our rifle. So you want to head over to your third person character, and in the event graph, you want to add a new event for playing that animation so that it can play that particle effect. So whenever you want to play particle effects or sounds in a multiplayer game, you need to add a event that will run on all clients, or is called a multicast. We want to right click and add another custom event. Just type in add custom event. And we're going to rename this to our multicast fire event, or our multicast fire rifle event. So select this event. We're going to change this from not replicated to a multicast. Compile and save. Now all we want to do is we want to get our rifle mesh. So that is our rifle mesh component. I want to get that on the graph and drag up here and call the play animation node. So we have this play animation. We'll select that and hook up the execution. And for our animation asset to play, hit the drop down and search for our fire rifle _W, that animation that we just inspected, and compile and save that. Now all we need to do is call this multicast fire rifle event inside of our line trace event. So go to your line trace function, and inside of here, we can, right after we do our line trace, we can call that multicast fire event. So compile and save, and now we should be able to see that animation be played when we fire our rifle. So it should play this animation on our rifle mesh, which includes both the fire effects, the muzzle flash, as well as the sound. So go in here and hit play. I hold my left mouse button down. You can see that we have the particle effect being played, as well as the sound cue. Now the player knows that the rifle is actually being fired off, and we have a visual representation of that. Head back to your third person character. The next thing that we want to do is going to add some hit effects. So essentially, if our line trace hits something, if it hits a wall, or if it hits the player, or anything on the ground, you just want to play a little particle hit effect. So the same thing that we did our multicast fire event, we want to add another multicast event for our particle hit. So I'm going to right click and search for add custom event, and rename this to multicast hit FX. And we're going to change this from not replicated to multicast and compile save and select this event. We also want to add an input because we need to know where to play this particle effect at the location. So add a new input. You want to change this from a rotator to a vector and rename this to our impact point. Basically the location where we should play this hit effect. So compile and save. Now off of this execution, we can call the node spawn emitter at location. So what this node will do is it will spawn sort of a particle effect at the given location. So under the emitter template, we can choose a particle effect. As you can see, there are some particle effects already included. And these are ones that come included with the military weapon silver, the asset that we downloaded from the marketplace. So in our case, we're going to use this P impact stone large. So this particle effect. And for the location, we're going to plug in our location like so. And then we can just compile and save that. Then we just need to call this multicast hit effects event inside of our fire line trace function. So double click, open up that function. And the way that we're going to call this multicast event is only if we actually hit the ground or some sort of surface. So what you'll notice is off this line trace, we have the out hit and also the return value, whether or not we hit something. So off of this return value, we can do a branch. And that will return whether or not we actually hit something. So if we do hit something, the true will get called. If we do not hit something, this false will be called. So if we do hit something, we'll just call our multicast hit FX. And for the impact point, we need to get that from our hit result. So off of this out hit, we drag up here, we can break the hit result. And that will give us some details based on the line trace that we did. So if you expand this, that will return things like the impact point, the location, if we actually hit something, all the details about that. So in our case, we want to take the impact point and plug that in for our impact point. So we can go ahead and unexpand that or collapse it and just compile and save that. So essentially, we're checking to see if we actually hit something. If we do, we call our multicast hit effects, and we're getting that impact point of where we hit that thing with our line trace and passing it to our hit effects event, which on the graph we spawn a emitter at the location or at the impact point. Now let's hit play, and if I left click, you can see that wherever we shoot, we'll play this sort of dust particle effect at the location. And just to visualize this better, we could turn off our line trace. If we go to our line trace function, select our line trace by channel, we can set this draw debug type to none, compile and save. And now we should just see the impact location particle effect. So now that we have some simple particle effects and we have a line trace function, what we want to set up next is we're going to need to set up the prop hunt character blueprint that will serve as the actual prop that the player has to hunt, as well as the prop hunt character abilities. So basically the prop will be able to morph into any other prop, and they'll be able to spawn fake props to sort of throw off the hunters. So let's go ahead and get started with setting up the prop hunt character blueprint. So let's go to our content browser, and in our core folder, we're going to go to the blueprints folder. And to create our prop hunt character blueprint, we're actually just going to duplicate our third person character blueprint, because our character blueprint already has the basic movement set up. So we're just going to use the same exact logic and save us some time by duplicating the character blueprint. So I'm going to right click and duplicate this and rename this to BP_prop character. So now double click and open up the prop character. So make sure that this is the prop character. And in here, we're going to select all of these nodes These shoot node, the stop fire, we don't need any of this logic since this is the prop, and delete that. We only want the movement input nodes. So compile and save that. And it looks like we're going to get a couple of different errors here. We also want to delete the function, this fire line trace function. Delete that and compile save. And also we can delete the fire timer and the bullet distance variables. So compile and save that. So this prop character should only have these movement inputs. And also if you head over to the viewport, we can select this rifle mesh and delete that. And for our character mesh, we're going to go ahead and remove this character mesh. So select this mesh, and under the mesh down here in the details, we can set this to clear it out. And so essentially we should have this empty character blueprint. Now for our character mesh, we're going to need to download some Unreal Engine Marketplace assets. Go ahead and open up the Epic Games Launcher and head over to the Marketplace. You want to search for construction, and you want to filter this by free. And so we should have a couple of different assets here, but you want to look for the construction site volume 1. So if you select on this, this is the construction site volume 1 supply and material props. So these are just a bunch of different construction prop assets. So we're going to be using this for our prop hunt game as different props that the prop character can actually morph into and change into. So once you go ahead and check this out and add it to your library, you can go ahead and click this Add to Project. You can click Show All Projects, search for your prop hunt game tutorial, and select it and click Add a Project. So that will go ahead and download it and add it to our project. Now we can go ahead, and what you'll notice is we should have the new construction underscore volume 1 folder in our content folder, which has a meshes folder, and it contains all the different meshes or different props. So for our prop character, if you head back to the blueprint, what we're going to add in here is a static mesh component for our character's mesh. So over in the components, we're going to add a new static mesh component. So select static mesh, and we're going to right click and rename this component to our prop mesh. Now with our prop mesh selected, in the details, we want to set the static mesh to one of the meshes that we have. So if we hit this drop down, we want to search for a SM underscore construction. We should have one of these construction cones. So we have construction pylon underscore 01E, or this little yellow cone. So this will be the default prop hunt character mesh. We'll just compile and save that. Now, to actually test this character out, what we can do is in our third person map, if I hit play, currently we're playing as the prop hunter or the soldier. I want to change this character and swap it out with the prop character, just so we can test things out. So the way that we can swap and use this character instead of the other character that we have is by changing it in the game mode. So to access the game mode, you want to go to Window, and you want to go to our world settings. So select the world settings. That will pop open this world settings window. And usually I have this window docked here, down here by the details. And you can place it anywhere, but just snap it down here by the details panel. In the world settings, each map has a game mode assigned down here. And if what you'll notice is we currently have the third person game mode assigned right here. If you expand the selected game mode, you can see that we have the default pawn class, which is our third person character blueprint. So to change our blueprint or our pawn class, you can just click this drop down and change it to our BP underscore prop hunt character. And now we should be able to play as the prop hunt character. So if we just save that and hit play, You now see that with this orange construction cone, you can move around and jump around. And I actually want to modify the camera position. We still have the old camera settings from our other character. But as you can see, we're playing as the prop hunt character. So let's go ahead and modify the character blueprint or the camera positioning. So if we head back to our BP prop character, let's select our camera boom. And we're going to go ahead and reset the socket offset. And also for our location, we'll reset the X and Y and set the Z to 32. We'll just move it down a little bit and compile and save that. And now we should have camera centered up on the prop itself. So we have the basic setup for our prop character. We have some movement. We can jump around and we have the camera movement set up. What we want to set up are some of the different props abilities, such as the ability to morph to another prop and also the ability to spawn fake props. So if we head over to the event graph, we already have the movement input set up. So we'll need to add the inputs for morphing into other props and also the other inputs that we'll need. So if we're changing props or for morphing into other props, we'll need to add the new input action for that. So let's go to our content drawer and go to our core inputs, actions, and right click and create a new input action, and name this to input action underscore change prop. And for this input action, we only want to get this called when we press the key. So we're going to modify this input action. So double click and open this up. And under the action, we have this triggers. So we can add a element for triggers. And you want to add a triggered for when we press it down. We're going to select the press. So this will ensure that this input action will only be triggered if we press whatever key we assign it to. So save that, close out of that. And now we just need to bind this or create a binding for this input action. So let's go to our IMC default or input mapping context. So double click, open that up, and we'll add a new mapping and click the drop down and assign it to our IA underscore change prop input action and expand this. And we're going to assign this by clicking the none and search for the E key. Just type in E, and we want to add a binding to the E key. So basically when I press the E key on my keyboard, it will call this input action change prop. Now you can set it to another key, but this is just the key that works best for me, or is usually the interact key in most video games. So that is what it's bound to. We can go ahead and save that. And now we have an actual binding for that input action. Let's head back to our BP prop character, and we can right click on the graph and search for our input action underscore change prop. So we have our enhanced action events, our input action change prop. We can add that enhanced input action. So now we have our triggered event. So basically when we press the E key, this triggered will get fired off. So now we need to add our logic for when we actually want to change or shapeshift to a different prop. So over here on the right, we're going to right click and add custom event. And we're going to rename this to change prop on server. So this will happen on the server. So to do so, we want to select this event and change this to a run on server and compile save. And we're going to basically call this off of our triggered. So we'll call our change prop on server. And then for this event, what we want to do is we're going to do a simple trace. So we're going to check and see if there's an object nearby the character that we can morph into. Essentially, we're going to do sort of a sphere trace to check and see if there's an object in front of the character or a prop that we can copy and change our character into. So we're going to use the sphere trace by channel node. So off of here, we're going to call the sphere trace by channel. So we have this sphere trace by channel node, so select that. Just like a line trace, it's going to ask us to specify a start and end location. And so we're just going to get the location of this character. So just right click and search for get actor location. So we can get the actor location of our prop hunt character. And we're going to add a little bit of offset to this value because we want the trace to be above the ground. We don't want to do the trace on the ground. Otherwise, that's just going to copy the ground mesh. So off of this return value, we'll just do a simple add operator. So operator add. And we're just going to add the Z value, give this a value of 10. So that will just offset our trace by 10 units, so it won't copy the ground. So hook this up for the start and end location. Then for our radius, we'll do a radius of 100. And just to showcase this, we can set a duration, a draw debug type for duration. So compile and save that. And now we should actually be able to see this in action. So if I hit play and press E, you can see that we're doing this sphere trace. And if I run up to an object, it will turn green if we actually hit something. So if I hit this mesh right here, it'll turn green. But if I don't hit anything, it will turn red. So this is exactly what we need, because if we see an object that we want to transform into, say this blue cube, if I press E, that will go ahead and do a trace. And if it hits something like this blue cube, we'll go ahead and transform into that object that we hit. Let's go back to our blueprint, and off of our sphere trace by channel, we have the return value if we actually hit something. So we can drag up here into a branch. So if we do hit something, then we want to go ahead and transform into that. So off of our out hit, we can rake the hit result and get some basic information about the object that we hit. So if you expand that, we can get the hit actor, and this will return the actor that we hit. And what we want to do is we want to get the static mesh component from that actor. So off of this hit actor, we want to do a cast to static mesh actor. So we're going to cast to the static mesh actor, hook that up for the true. And if we do hit a static mesh actor, we want to get the static mesh from that actor. So the way that we'll do that is we're first going to get the static mesh component, get static mesh component, and then from that component, we can get the actual static mesh. So drag up there and then get static mesh. That will return the static mesh. So now that we have that mesh, we can go ahead and set our characters mesh to that mesh. So in order to do that, we need to create another event that will happen as a multicast so that everyone can see this change happening. And so what we'll do is we'll right click and add custom event and rename this to update mesh multicast. We want to set this to a multicast. And we also want to pass the mesh that we are changing to. So we'll need to add an input and change this to a static mesh object reference. So you want to change that to a static mesh object reference and rename this to new mesh. We'll compile and save. And now we can call that event. So up here off of the execution, we can call the update mesh multicast event. And for the static mesh, we can just plug that into the new mesh. So now that this event is being called, we can set our prop mesh to the new mesh. So get our prop mesh component and call the set static mesh node and hook up the execution, and now hook up for the new mesh like so. We'll compile and save that. Now we should be able to test this out in action, but first we'll need to add some props in the level. So let's go to our construction volume 1, meshes, and we'll just drag in a couple of different props like this construction cone. You can also drag in this crate. and also maybe something like this barrel, and maybe this cinder block. So hit play, and now if I run up to this object and press E, you can see we're now changing to this prop. I'm going to press E on this one. You can see that now we're this cone, press E, and now we're this crate. You can also press E on the cinder block, and now we're this tiny little cinder block. So basically, whatever we hit and do our trace to is whatever object will transform into. Now we have a very simple morphing logic. So basically, our prop can morph or change into any other prop that's in the level. The next logic that we want to set up for our prop character is we want to give the prop character the ability to spawn in a copy of itself. So basically, if I change into this crate, I want to be able to spawn multiple crates to sort of throw off the player and make them think that I'm any of the other different types of props. So I want to give the prop that ability. So to do that, we're going to first add an input for that to spawn a prop. So let's go to our core input actions and add a new input action. So right click and add a new input action. And we'll rename this to IA underscore spawn prop. And double click open that up. And same thing inside of this input action spawn prop is we're going to add a new trigger. So add a new trigger, and we're going to change this to a pressed. So if we press this key, this input action will be triggered. So save that and close out of there. And now we just need to bind it or create a binding key for that input action. So go to your input, open up the input mapping context, and we'll add that new mapping for our input action underscore spawn prop. Expand this, and we're going to add a key binding for our X key. So under this none, search for X, and we're going to use the keyboard X. Save that, and now let's head back over to our prop character. Now really quickly, I'm going to add a comment for our change prop logic. So if you drag and select all this, you can press C. Now we'll go ahead and add a comment. And we'll name this to change prop. I'm going to click this show bubble when zoom. That way we can see what this is named to. And this will just keep our code nice and organized. So compile it and save. But now we should be able to add the other input action for our spawn prop. So right click down here on the graph and search for our IA underscore spawn prop. We can add our input action spawn prop. So same thing like what we've done over here is we need to add an event that will run on the server. We're going to right click and add custom event. This will be called spawn prop on server. We want to change this from not replicated to a run on server. Compile and save that. And off of our triggered, we'll call our spawn prop on server event. So next up, for our spawn prop on server, what we want to do is we want to spawn a blueprint that will be a copy of this prop. So we're actually going to create a new blueprint actor that will serve as the prop that we spawn. So we need to go to our core folder, blueprints, and in here we're going to right click and create a new blueprint. So if you never created a blueprint before, basically you just right click and you have a basic asset. You can create this blueprint class. So we'll select that, and you want to choose this actor. So this will just be a simple actor that we're going to spawn. Select the actor and rename this to our BP underscore spawned prop. This will be our spawned prop actor. Now inside of this actor, just double click, open this up. We're going to have a couple of settings that we want to change. The first setting that we want to change is you want to go to the class defaults. So click on this class defaults. We want to uncheck start with tick enabled. We're not going to use the event tick. And then we want to make sure that you check replicates. Very important that you do this. Otherwise, you're going to have some issues in multiplayer if you do not replicate this actor. So very important that you hit this checkbox to true. Now the last thing that we'll do in here is we're going to add a component. So under the components, we're going to add a new static mesh component and just rename this to prop mesh. So compile and save that. And now that should be all that we need set up. So we can close out of there. Now that we've created that blueprint class, we can go back to our prop character. And off of our spawn prop on server, we can call the node spawn actor from class. So we have the spawn actor from class node. So that will spawn an actor based on a blueprint class that we specify. So in our case, we can search for that BP underscore spawn prop, the spawn prop blueprint that we just created. Then for the transform, we want to get our prop mesh component and get world transform. We're just going to get the transformation, get world transform, and plug that in for the spawn transform. So compile and save that. Then lastly, we need to set the mesh of the spawn prop. So we're going to create a multicast event. That way, everything will be shown to all the players that are connected to the server. So we're going to right click and add custom event and name this to a multicast set mesh. We want to change this from not replicated to multicast. And we'll also need two inputs. We need a reference to the blueprint, and then we also need the mesh of the prop so that we can change it. So on this multicast event, we can add two inputs. And the first one will be a reference to the blueprint class. So we're going to change the first one to our BP underscore spawn prop. And we want to change this to a spawn prop object reference. The first one will be called reference. And the second one will be a static mesh object reference. So make sure that this is set to a static mesh object reference. And we'll rename this to new mesh. So compile and save. Then over here, we can call that multicast set mesh. So for the reference, we can plug in the return value like so. And for the new mesh, we can get that from our prop mesh. So we'll get our prop mesh component and get static mesh. Get the static mesh of that and pass that to the new mesh. We're getting the mesh of our character, and then we're passing it over to our multicast event. And over here, all we need to do is, off of this reference, set static mesh of our prop mesh component. So that is in the spawn prop blueprint. And then for the new mesh, just plug in the new mesh like so. Now we should have our basic spawn prop logic set up. So we can actually add a comment for all of this. This will be our spawn fake prop logic, show bubble when zoomed. So all we're doing is when we press this input action spawn prop, which is the X, we're going to spawn this actor, this blueprint actor, and we're going to get the mesh of our character, current mesh, and set the spawn prop to that mesh. We'll compile and save, and now let's hit play. So if I press X, you can see that it spawns that prop. If I press E to copy this barrel and press X, you can see that it spawns it like so. So we can press E, press X, we'll go ahead and spawn it. So wherever I'm located, it will go ahead and spawn that prop like this. Now, if you do not like the way that it automatically merges the character, so we can actually turn the collision off. So if you don't like the way that it sort of moves the character around, we can turn the collision of the spawn prop. So I'm actually going to turn that off. So if you open up your BP spawn prop and select the prop mesh, the static mesh component, we can, in the details, set collision from block all dynamic to no collision. So compile and save that. And now if we go ahead and spawn a prop, you can see that we can not be blocked by the collision itself. And basically we can sort of hide in the props that we spawn and position them wherever we need to position them. So now we have our basic copy as well as our basic spawn prop logic for our prop character. So now that we've created the prop hunt character blueprint and the basic prop hunt character logic, the next thing that we'll need to set up is the game mode logic for our prop hunt game. So essentially the game mode is the class that will contain all the rules and logic for the game. So essentially when the game should start, if there's enough players to start the game, and who should be the prop character. So essentially the game mode will contain all that logic for starting the game, managing the game, and determining who is the winner or the loser of the game. We'll need to go ahead and create this game mode. So to create a game mode, you want to go to your core blueprints folder. And we're going to right click and create a new blueprint class. So you want to create a basic asset blueprint class, and you want to select the game mode base. So you can see the game mode base defines the game being played, its rules, scoring, and other facts of the game type. So we're going to select the game mode base, and we're going to rename this to GM for game mode _ prop hunt game mode. This is our prop hunt game mode class. Now to open this game mode, let's double click and open this up. So once you open up the game mode, you close it and open it up again like this, you'll get this details only view. Okay, so this will only show you the basic details of the game mode. But if you want to open up the full blueprint editor, you can click open full blueprint editor like so. And that will open up the graph, the viewport, and all that stuff. Now, if you head over to class defaults, over here on the right, we have the basic details about this game mode, things like the pawn class, the player controller, and much more. Now, what we want to do is we want to assign our default pawn class. So under the classes, we want to, under the default pawn class, change this from default to our third person character. So our third person character is that prop hunter or the soldier with the gun. So we'll set it to that, compile and save. And now we want to set our game mode. We want to set this as our default game mode. So if you remember in our world settings, we have a game mode. Currently we have the third person game mode, but we want to set it to our prop hunt game mode. So if we change this, we can hit this drop down and set this to our GM prop hunt game mode. And now you can see that it takes our third person character as the default pawn class, because that's what we set as the default pawn class in our game mode. So if I hit play, we should see we're now playing as the soldier or the prop hunter by default, which is what we want. So by default, the character will spawn in the game as the prop hunter. And now in the game mode, or in our blueprint, our game mode prop hunt game mode class, we can actually start setting up the logic to determine who should be the prop character and who should be the prop hunter. So in here, we're going to delete these events on the graph and compile save. We don't need anything on the graph. We'll start off with a fresh start. But in here, we want to add an event when the player joins the server. So we have this event, and if we right click and search for it, it's called event on post login. So this is the event that gets called if a player joins the game. So we want to call this event on post login. So basically, if the player joins the game, it will give us a reference to the controller. The player controller is what controls the player character, and that's what we're going to use to keep track of the players that have joined the game. So we're actually going to save this. So if we take this value and promote this to a variable, we can rename this to players. We actually want to delete this variable, compile, save that, because we want to take this players variable and change this from a single variable to an array. So if we, over here on the variable type, change this from a single, we want to change this from a single to an array, because we want an array of player controllers, or basically a list or references to all the players who have joined the game. So now that we have this players array, we can actually get this on the graph, and we can add to it by using the add operator. We have array add, and we can add the new player that joins to our list of players array. So basically, we're kind of storing a reference to all the players that join so that we can keep track of all the players. Then once a player joins, what we want to do is we want to check and see if our game is in progress. So we're going to add a new variable, name this to has game started, ? And change this to a Boolean. You want to change this from an array to a single variable. So we're going to get this Boolean on the graph and do a branch. And hook up the execution. We want to check and see if the game has started. So if the game has started, we don't want to do anything because we don't want to ruin our current game in progress if a new player joins the game. But if the game has not started yet, then we want to go ahead and check and see if we have enough players to then start the game. So we're going to get our players array. Get the players array and do a length. Get the length, or get however many players are currently on the server. We want to check and see if this is greater than or equal to the number of 2 players. So do we have at least 2 players on the server? And then we can do a branch off of that check. Hook this up for the false. So basically, if the game has not started, we're going to check and see if we have at least 2 or more players. If we have at least 2 or more players, then we can go ahead and start the game. So we're going to go ahead and start a timer. So down here, I'm going to add custom events. This will be called start game timer. This will be a countdown timer to when we actually start the game. So compile and save, and off of our true, we can call that start game timer. So now that'll call this event the start game timer, and we can add a set timer by event node. So the set timer event will count down however many seconds we want. So I'm going to give this 4 seconds. So basically, if 2 or more players join the game, after 4 seconds, we're going to start the game. You can give this more time. You could add it to a minute so that you give more time to other players who want to join the game or want to participate. But for testing purposes, I'll just set this to something low, like 4 seconds. Then off of the event, we want to add custom event and name this to choose prop character. Because once the time is up, we're going to go ahead and start the game. And by doing so, we need to go ahead and select the prop character, who's going to be the prop character and who's going to be the hunters. So now let's go ahead and set up the choose prop character logic. So for this, we're going to get our players array. So we're going to get all the players that have joined the game. And we're basically going to get one of the random players and make them the prop character. So off of here, we're going to do a length. Get the length, get however many players have joined the game. And we'll do a random integer in range. Now unhook the min by alt clicking right there. We want to hook up the length to the max. So however many players have joined the server is our maximum integer that we can pick, but our minimum will be 0. That should return a random integer within that range. Now we want to get the player from this random integer. So off of this players, we can do a get array get a copy. We want to get it at that random integer. And then whatever this value is a reference to the player that we've selected to be the prop character. So we can take this variable or this value and promote that to a variable and name this as the prop hunt player. So this is now the prop hunt player. Now before we hook this up, what we also want to do is we want to set our game started to true. Because now that we've started our game, we want to set this game started to true. That way, we don't call this logic again. We don't select another prop character if another player joins the game later on. So we're just keeping this little check. Now hook up our execution. So what we're doing is we're picking a random character from our player controller list or player list, And we're setting them as the prop hunt player. Then we just want to do an extra check to make sure that this player is valid. So off of here, we want to do a is valid check. We just want to make sure that the player actually exists. They're still connected to the server. And then if so, we can spawn the prop hunt character and let this controller possess that character. Now, if this player has somehow left the game, or if this reference is not valid, we can go ahead and do a delay. Do a little delay of, say, 1 second before we go ahead and recall this event. So we can choose a different character to be the prop hunter. So we're going to call the choose prop character event right up here, so that we can go ahead and select a new character to be the prop hunt player. So now next up, we want to go ahead and spawn the prop character. So we want to do a spawn actor from class. And the class that we want to select is our BP underscore prop character blueprint. So select the prop hunt character blueprint class. And then for the transform, we're going to use a special location. So we're going to actually right click the transform and split the structure pin. That will give us the location, rotation, and scale. But in our case, we only want the location. So basically, we're going to define where should we spawn the prop hunt character on the map. So we're going to take the spawn transform location and promote that to a variable. And let's go ahead and right click and just rename this to our prop start location. So this will be wherever we want the prop to spawn on our map. So we can make this far away from the hunters. That way we can give the prop a head start to hide. So for example, we can have the prop start over here. So if I get the location of this cone right here, if I select that cone and in the details copy the location, I'm going to take that location and go into our game mode, select the prop start location and paste that, compile save, and now we're using this custom location in the game wherever we specify. That way we can have it away from where the hunters will spawn. So we're using that location to spawn the prop hunt character. Next up, we need to take this character and let the player controller possess that character. Also, the character or this controller, technically they spawn in with our third person character. So we need to go ahead and destroy that character as well. Because they spawn in as a hunter, all of the players spawn in as hunters because that's the default pawn. So that means that that player, we need to destroy their character reference because they're going to be playing as a prop instead. So the way that we'll do that is we're going to get the prop hunt player controller reference, get that on the graph, and we want to get the controlled pawn. So get the controlled pawn, or the pawn that this controller is controlling, and we want to destroy it. We'll just call destroy actor. So that will go ahead and destroy the character that they were using. And then after this, we'll give it a delay of, say, 0.2 seconds. And then we want to go ahead and possess this character. So off of our prop hunt player, we can call the possess node. And so the target is the prop hunt player. The in pawn, or the pawn that we want to possess, is this prop character blueprint. Plug that in for the in pawn. And now we should be able to see this logic happen. So essentially, to recap, what we're doing is when players join the game, will be saved to this player array. If the game has not started yet, we're going to go ahead and check and see, if there's enough players to join. So if we have at least 2 players, if so, we're going to go ahead and start a countdown timer, about 4 seconds. And after 4 seconds, we're going to go ahead and set the game has started to true. We're going to choose a random player from our list, and then we're going to check and see if they are valid, if they are still connected to the game. If so, we'll spawn in the prop hunt character blueprint. We'll destroy their current pawn that they have, and we'll possess this prop hunt character as their new pawn. So to test this out, we're going to need to play this as 2 players. So if you never tested multiplayer in Unreal Engine before, essentially what you want to do is you want to come up here to the play button. You want to click on these 3 dots because we want to play this as multiplayer. So I'm going to play this as new editor window. So if you select that, it will pop open this additional window. I'm going to change that to new editor window. And then I'm also down here, I'm going to change the number of players to 2. So we have 2 players. Then I'm going to change the net mode from standalone to listen server. So essentially, the number of players will determine how many players you want to have connected to the server. And the net mode itself will determine what net mode you're playing as. So the standalone is single player. Listen server is sort of as a server and client. And then client is just as like a dedicated server. So there's different types of net modes. I'm not going to really go in depth in the different types, but basically you can just follow along and set this as a listen server, 2 players, and play in new editor window. So now if we hit play, we should have 2 separate windows pop open as 2 separate characters. We have character number 1 and character number 2 on the left. Now what you'll notice is it automatically saw that 2 players were connected to the server, and it made me the prop character. So if I go ahead and exit out of there, you're going to see that we have this warning message, not enough login credentials to launch all Pi instances, change editor settings. And this is just a warning message. This is actually not even relevant. We can just clear that. And we don't really need to worry about that. That's just a warning message. But if I hit play again, we can see this happen. So we're 2 players. Pretend that we both connected to the server. Now it's going to select a random player to be the prop, and the other player will be the prop hunter. As you can see, it selected client 1 over here on the left to be the prop. And now client, or the server, over on the right is the prop hunter. So over here on the left, the client 1 is the prop. So you can see I can run around, jump around. I can even press E to copy a prop and press X. Now we'll go ahead and spawn props, and you can see that everything is replicated. So all the other players that are connected to the server can see everything happening. And also on the server over here, you can shoot and fire our rifle at the various different props. So as you can see, our basic game mode logic is working because it will randomly select a player that joined the game and set them as the actual prop. And the rest will be the prop hunters. So now that we have our basic game mode logic working, what we'll need to add next is some widgets on the screen so that we can see who is the prop hunter and have some basic instructions for the players, as well as a health bar for the prop character. So what we'll need to do to add those widgets is we'll need to go ahead and create some widget blueprints to add that user interface to our screen. So in our core blueprints folder, we're going to right click and create a new blueprint class, and we're going to create a player controller blueprint. The player controller is what controls the characters. It's what we'll need to create user interface because the widgets will be attached or controlled and created by the player controller. So select the player controller, and we're going to name this to our PC underscore prop hunt controller, and do a file, save all. So now that we've created this player controller, we need to assign it in our game mode. So if you open up our game mode prop hunt game mode, we want to go to the class defaults, and over here under the classes, under our player controller class, we want to change this to our PC prop hunt controller. So compile and save. And also in the world settings, you should see that update. So now we're using that player controller prop hunt controller that we created. The next thing that we'll need to do is we'll need to create our widget or our main HUD that we're going to show on the screen. So let's go back to our core folder. We're going to right click and create a new folder and name this to widgets. And so double click and open up this widgets folder. And in here, we're going to create our main HUD. So right click, and if you never created a user interface widget before, basically you want to go down here to the user interface and add a new widget blueprint. And it will ask us to pick a parent class. We're going to use the user widget. Then we're going to rename this to our widget underscore main HUD. So this is our main HUD or heads up display. And then just do a file save all. And we can double click and open this up. So in this user widget, if you never created user interface before, essentially here in the center, we have this sort of graph. This will show us what the user interface will look like, sort of a preview on our screen. On the left here, we have a palette, which has different things that we can add to our user interface. Things like buttons, images, borders, scroll boxes, text, and so much more. Over here on the hierarchy, this is basically like the hierarchy of what is attached to what and all of the different assets that we add. Then over here on the details, this is just various details about what we have selected. So if I have a button selected, it will show me, the style, the image, all that stuff. Then you can see we have two tabs up here at the top. We have a designer. This is where we can design what it looks like. Then we have a graph, which is where we can actually program and add functionality to things like the buttons, the text, all that stuff. So if we head over to the designer, we're going to go ahead and start by setting up our basic main HUD. So the first thing that we'll need to add is you want to search in your palette for a canvas panel. We need to add a canvas panel to work on. So now that we've dragged and dropped that onto our hierarchy, we should have this box or this canvas that we can start working inside of. Okay, so you can sort of think of this as your screen, as like the player's screen. Now onto this canvas, we're going to add some text. So we can add some text, which for text, we're going to add this text onto our canvas. So you can drag it either onto your screen like here, or you can drag it onto the hierarchy, and it will add it underneath the canvas panel. And now with this text selected, we can place it anywhere on the screen. But in my case, I want to place it up here, sort of at the top center. And we have these anchors. So what you'll notice is we have sort of like this flower right over here. I wanted to anchor this up here in the center. So the anchor is what will hold this particular text, depending on if I scale my screen or if I'm playing on a smaller screen or a different screen, whether it's full screen. The anchor is what will anchor that widget text to wherever we need it to be positioned. In our case, under the anchors, we want to anchor this to the top center, so, and that will move the anchor over there. Now for the positioning, we can further position this wherever we need to. But right now, I think that is good. So for the content itself, we can change the text. Right now it says text block, but over here in the content, we can change that by highlighting this and changing this to waiting for more players, ... Something like this. And we can just center this text by, under the justification, center aligning the text. Also, we can scale this text up, because right now it's pretty tiny. So we can, under the font size, appearance font, we can scale the font up to a font size that we might want. I'm going to set this to 50. Now we can compile and save that. So we've added the simple text that just says waiting for more players. And let's actually add this to our screen. So to add this text or this main HUD widget to our screen, we'll need to add it inside the player controller blueprint. So that blueprint that we just created for our player controller, which is in our core blueprints PC prop hunt controller. If we double click and open this up, we want to head over to the event graph. Over here on the event graph, we can delete these events. I'll save. We want to add an event begin play. So right click and add event begin play. Basically, when the player joins the game, this event begin play will get called. And then off of here, we'll go ahead and create the widget or the main HUD and add it to the player's screen. So the first thing that we're going to do is we're going to call the switch as authority. And so off of the authority, this will only get called on the server meaning if this is a server player or a listen server, this will get called. If this is a client, meaning this is a player who's actually playing the game, this remote will get called. So we only want to create user interface if this is either a player or a listen server who's also a player. Now, if you are a dedicated server, if you have a dedicated server, we don't want to create user interface because that's just a dedicated server. It doesn't need any user interface created for it. Now, without getting too much more in depth about that, we're just going to continue on with setting this up. Basically, off of the authority, we want to do a branch. We just want to do one extra check. We want to check and see if it is a local player controller. So hook that up for the condition. If we are a local player controller, we can go ahead and create widget. Call the create widget node. And also for the remote, we want to plug that in for the create widget node. And then you can double click on the pin to add a reroute node. So that will just tidy things up. But for the class, we can choose what widget we want to create. And so for the class, we can hit the drop down and select our main main HUD class. And for the owning player, we can get reference to self. We get a reference to this player controller, file and save. Then we just need to go ahead and save a reference to this main HUD. So off of this return value, we can promote this to a variable and rename this to main HUD ref and compile and save. And then we want to take this and add this to the viewport. So we can do a add to viewport. Now we'll go ahead and add that widget to our viewport. So I'll compile and save that, and we can just add a comment for all of this. So select all this and add a comment. And this will be called create widgets for clients. This will just create the widget for the main HUD if the player is a client. Now if we hit play, we should see waiting for more players on both the client and the listen server. And currently the game has started. So basically when the game starts, we want to change that text to, the game has started. If they are a prop hunter, we want to say, now your objective is to hunt the prop. But if we are the actual prop, we want to say, you are the prop, you have to go and hide. So we have our widget shown on the screen or our main HUD. Now let's actually update it or update this waiting for more players text when the game has started. So to go ahead and update or create an event that will update the text, the way that we'll do this is using Blueprint interfaces, because we need to communicate from the game mode when we spawn in the prop character. We need to communicate from the game mode to the controller to then update the HUD user interface. So if you never used interfaces before, essentially it allows you to communicate from one blueprint to another. It is one of the most efficient ways and effective ways to communicate between two different blueprints without the need for using something like casting. Now, if you're confused about this topic, I go more in depth in a separate video on Blueprint for Advanced Users. So if you want to check out more about blueprint interfaces and casting, you can check out that video. But in this video, we will show you how to use blueprint interfaces and how to communicate between two different blueprints using them. Let's go ahead and create our first blueprint interface. So in your blueprints folder, we're going to right click and create a new folder and name this to interfaces. And then just double click and open this up. And in here, we can right click and create a new blueprint interface. So under the advanced asset, we want to search for blueprint. And down here, we want to go down to blueprint interface. So go ahead and select that. And we're going to rename this to our BPI underscore prop hunt controller. So BPI for blueprint interface, and then our prop hunt controller. So just do a file, save all. And now if we double click and open up this blueprint interface, we're going to see that we have this graph in the center that says read only. And then over here, we have these functions that we can add. Then down here, we have this details panel. Now we're going to create our first blueprint interface function. So we're going to select this function. And if you right click and rename it, we're going to rename this to setup prop widget. So it's going to be called setup prop widget, and we want to have an input. So down here in the details, we have inputs and outputs. So we can pass variables between one blueprint to another using inputs or outputs. If we want to retrieve variables, in our case, we want to pass a variable. So we're going to add an input. And it's going to be of the type Boolean. And then we'll rename this to isProp ? And compile and save that. So whether or not we're a prop, we're going to set up the widget depending on if we are the prop or if we are the hunter. So close out of this blueprint interface. We now want to add this blueprint interface to our player controller or our prop hunt controller blueprint. So to add a blueprint interface, all you have to do is head over to the class settings by clicking on the class settings button. And in the details down here under the interfaces, we want to expand implemented interfaces. So under the implemented interfaces, we want to click add and search for our BPI_ prop hunt controller interface. So select that, and now it says that we have our BPI prop hunt controller interface implemented. Let's just hit compile and save. And now what we should notice is down here under the My Blueprint, we have this new section for interfaces. And if we expand it, we have that interface function or that interface event that we added when we set it up, which is called setup prop widget. So if I double click on this will go ahead and add that interface event. So you'll notice that this is an event since it says event and it's color coded in red. But we now have an event for when we want to set up the prop widget. So whenever we're setting up or managing widgets in a multiplayer environment, we only created widgets for clients, which means that we have a reference to the widget, but it's only created on a client. So this means that whenever we call this interface event, we'll need to create another event that will get called on the client if we want to access our main HUD. So again, this is just another thing with setting up multiplayer. There are just certain rules that you need to abide by when creating multiplayer games. So to do this, we're going to right click and add a custom event. Rename this to set prop on client. And we're going to change this to a run on owning client. And also we're going to need to have an input of the type Boolean. Rename this to isProp ? And compile and save. So now we can call this onClient event after this event, after this interface event. So off of here, we can call the set prop on client event. We'll call this custom event down here. And now what we can do is we can get our main HUD ref. This is a reference to our main HUD. And now on our main HUD, we can call another event inside of our HUD that will actually go ahead and update the widget. So to do that, we need to go into our W main HUD, and we need to select this text. And with the text selected, you want to make this a variable. So check this little checkbox is variable. And also let's rename this. We'll rename this to our prop text and compile and save. And now that we've set this to a variable, we can actually modify the text value right here. So if we head over to the graph, we can, on here on the graph, add an event for updating that text. The first things first, let's actually delete the current events that we have in here. I'll save that. Now we can add a custom event by right-clicking and add custom event. And we can rename this to setup prop widgets. And we're going to have an input. So under the details, we can add inputs. We'll add a new input of the type Boolean, and this will be isProp ? And compile and save that. So now to update the text, since we set this text as a variable, if we head over to the graph, we now have the prop text as a variable, which we can modify. So we can take this prop text and get it on the graph and do a set text. So we have this widget set text down here at the bottom, and that will allow us to set the text of this widget right here. We want to hook up the execution, and for the in text, we want to do something different based on if the player is the prop or if they are the prop hunter. So off of this in text, we're going to do a select text function, select text. And for this Boolean, we're going to plug in the Boolean like so. So off of the A, basically if the A is true, the A will get called. If the Boolean is false, the B will get called. So if we are the prop, we want to type in you are the prop, exclamation mark, hide, exclamation mark. Now for the B, if we are not the prop, meaning this is false, that means that we are the hunter. So we want to do find the prop. So basically it will update the text based on if we are the prop hunter or if we are the prop. Now that we've created the simple setup prop widgets event, we can call it in our controller. So head back to the controller. And now off of our main HUD reference, we can call that setup prop widgets event. So plug that in like so. And for our is prop, plug that in for the is prop. So compile and save that. So essentially, we set up the interface event, which will call this event on client, which will get our main HUD reference and call this setup prop widgets in our main HUD, which all that does is it checks and sees if we are the prop, we're going to set this text on our screen to you are the prop hide, or if you're the prop hunter, we're going to say go ahead and hunt the prop. So now we can call this interface in our game mode based on if we are the prop or if we are the prop hunters. So if we go to our game mode over here, we first want to call the interface on the prop itself. So we have a reference to the prop player. So off of here, we have a reference to the controller. So if we drag off here, we can call that interface setup prop widget interface message. So that is our interface event that we created. So if we select that, we can go ahead and move this up. Basically set this to true because they are the prop. And so that will call and update that widget for the prop. However, for all the other players or for the hunters, we'll need to also call this event for those players. So the way that we'll do that is first we'll need to get the players array. That will get all of the players on the server. And we're going to do a for each loop. So we'll do a for each loop. So that will loop to every single player where we can then call that event. So first let's hook up the execution. And then what we want to do is we want to do a check and see if the player controller, that player connected, is valid. So we'll do a is valid check. Just to make sure that this player reference is valid. That way, are they still connected to the game? Are they still playing the game? All that stuff. If so, we want to go ahead and do another check, which is basically we want to make sure that this player is a hunter because we already set up the widget for the prop player. We want to set it up for the hunters now. So what we're going to do is we're going to get the prop hunt player. We're going to get that on the graph. We're going to do a is valid check. So we're going to right click this and convert this to a validated get. Look this up for the is valid. So we're just checking to see if prop hunt player is also valid. And then we want to compare this prop hunt player controller to the player controller over here. So we just want to make sure that this is not equal to this player reference right here. Okay, if the prop hunt player is not equal to this player in the player array, we'll do a branch. If it is not equal, that means that they are a prop hunter, which means that they are a soldier. So then off of this array element, we can call the setup prop widget message or interface. Look that up for the true, and we want to set that as false, meaning they are not the prop. They're the prop hunter. So this will ensure that we will call our interface setup prop widget for all players who are not the prop hunt player. Okay, so if they are not the prop, we're going to update the widget so that they know that they have to go ahead and find the prop and hunt them down. So now we've set up our logic for showing our prop widget text. So if we go ahead and hit play, you can see that it says waiting for more players. After about 4 seconds, it will select the prop hunt player. So you can see this player on the left is the prop. It says you are the prop hide. Then the player on the right, it says find the prop. So now we know that it's updating our widget, our main HUD, and it's updating the text when the game has started to show the player what the objective is. So now that we've added our main HUD widget, we can start working on adding other things to our user interface. Also things like a crosshair so that we know where we're aiming at specifically for our prop hunters. So let's go ahead and import a custom crosshair that we can add to our screen. So with the project files downloaded, we want to go to the project files miscellaneous folder. We should have this crosshair right here. Then you want to go to your widgets and right click and create a new folder in here called textures. Just double click, open that up. Then just drag the crosshair.png into the textures folder. And then lastly, we need to set this as a user interface. So double click and open up the texture, the crosshair texture. Set the texture group from world to UI. Save that, close out of there. Now it should be ready for us to use. So we're going to add this little crosshair to the center of our screen on our main HUD. So go to your widgets main HUD, and in here to simply add this crosshair image. In the palette, you can just search for an image. We can drag and drop it on our canvas panel on the screen. And to center this image up on the screen, we can take this and anchor it in the center. And we can reset the X and Y to 0, 0. We can also change the size to 100 by 100. So it's a square. And then to get it perfectly centered in the middle, we can give this an alignment of 0.5 and 0.5. That will automatically center this directly in the center of our screen. Now for the brush, you want to expand under the appearance, and under the image, we can set our cross hair image. Now we should have that set, so we can compile and save that. And if we go back to our game and hit play, we now have this crosshair here in the center of our screen, which will basically show us, where are we shooting at. Now, the other thing that we need to add to our user interface is our prop needs to have some health. Essentially, when I shoot at the prop itself, the prop needs to be able to take damage, and it needs to have a health bar on the screen so that the prop can know how much health it has left. So the way that we're going to do this is we're going to go to our main HUD, and we're going to add a health bar onto this main HUD, but we only want to show it for the prop character. So that means the prop hunters, they don't need health because they are the hunters. They're not going to be able to take damage. So first, let's work on adding the widget or the health bar widget. So in our palette, we want to search for a progress bar. So we have this progress bar. We can just drag and drop it onto our main HUD. And then we can drag and resize this up. So something like this, just a rectangular shape. We can select this. We want to anchor this to the bottom right. And then we want to go ahead and give this a fill. So under the details, under the progress, we can set the percent all the way up to 1. We can also change things like the fill color and opacity. We can change the color. So if we expand this or select on the blue there, we can change this to maybe a dark red color, something like this. And compile and save. And then let's select this progress bar and make sure that this is set to a variable. And we'll rename this to our health bar. Compile and save that. Now the thing is, we've added this health bar, but currently it's added to both of our characters here. We want this actually to be hidden by default. We only want to show it for the prop and not the hunter. So the way that we'll do that is we're going to select this health bar, and in the details, Down here under the behavior, we have this visibility. So we can set this to hidden by default. And now if we hit play, it should be hidden by default on the screen. So the only way that will show this health bar is in our graph when we set up our prop widget. So if you head over to the graph, we have this setup prop widgets. So essentially, if we are the prop, we set the text here. If we are not the prop, we set also the text here to find the prop. So we can use the same Boolean over here and do a branch. And whether or not we are the prop or not the prop, we can set the visibility of this health bar to visible or hidden. So take our health bar, and if we are the prop, we can set the visibility, of our health bar to visible. Compile and save that. Now let's hit play. And we should see after we're waiting for more players that will spawn in as the prop. Here we are the prop. And now you can see I can only see my health bar on prop screen. And the hunters don't need health because they are hunting the prop. So next up, what we need to do is we need to actually set up this health bar. And we need to give the prop some health, as well as the hunter's ability to damage the prop. Essentially, when the hunter shoots, if it hits the prop itself, we need to apply some damage to the prop and update that health bar widget. Let's first work on damaging the prop. So the way that we're going to do our damage is we need to go to our blueprints, open up our third-person character, and we need to open up this function, our function rifle line trace. So right over here where we're firing off our line trace, we're checking to see if we hit something. We play our hit effects. What we want to do is we want to check and see if we hit an actor. So off of this hit result, you want to expand this, and we have this hit actor. So this is the reference to the blueprint actor that we hit. So we want to check and see if this actor is our prop character. So let's actually close everything other than our prop character and our third-person character. And now the check that we want to do is we want to check and see if this prop character has a tag. So we're going to be using tags to check and see whether or not this is the prop character. So to use a tag, we can go to the BP prop character. And if you go to the class defaults, in the details, we can search for tag. And down here under the actor section, we can add our own custom tag. So tags can be used to determine whether or not an actor is something that you need to apply damage to or not. And so if we add a new tag down here and name this to prop, we can keep track of whether or not this prop character is a prop character by using this tag. So let's compile and save that. Now let's keep in mind this is the tag name. You want to make sure that you keep note of the name of the tag. The capitalization, punctuation is very important. Now in our third-person character, off of our hit actor, we can check and see if the actor that we hit, actor has tag. If the actor has the tag prop, so this is the same exact tag that we set up in our prop character, the same exact capitalization, make sure that is the same exact tag. Then off of here, we can do a branch and hook this up like so. So if it does have the tag of prop, that means that we have hit a prop character. Then all we have to do is apply some damage to that prop. So the way that we'll apply some damage is off of this hit actor, we have a node that can apply damage. So all you have to do is search for it up. It's called apply damage. We have damage, apply damage. So this is a built-in function that comes with the engine that will apply some damage to an actor that we specify, or in this case that we hit. To hook this up for the true, for the base damage, we're going to specify how much damage we should apply. I'm going to leave this as 5 damage. And then we need to specify our damage causer, which is an actor object reference. Just drag off here and get reference to self, because this is the actor. The third person character is the actor that is causing the damage. And then we need to select a damage type class. So if you hit this drop down, we have this damage type class, blueprint class, the default one, named a damage type. Just select that and compile and save. So now we've set up our apply damage function. So we're only going to be hitting our prop actor or blueprint. We're only going to be applying damage to that prop actor blueprint. Now, next up, what we need to do is set up the receive damage in the prop character blueprint. So we can close out of the third person character and go into the BP prop character. And over here on the event graph, we can set up the receive damage logic. So right click on the graph and search for event any damage. And we have this event any damage. So go ahead and select that. So essentially, whenever we receive any sort of damage, this event will be called, and this will return how much damage we have received. So the first thing that we'll do is we're going to do a switch has authority. So we're just going to make sure that our logic thus far runs on the server, since this is an important event. And then we're going to take our damage. We need to subtract our health minus the damage or the incoming damage that we receive. So we'll need to add a health variable to our prop character. So under the variables, we can click on this plus icon to add a new variable. And we can name this to health. And we'll change this variable type from a Boolean over to a float and compile and save that. Now for the health of our prop character, we can set the default value of this to 100. That way we have 100 HP by default. Now we can get our health on the graph and do a subtract. Operator subtract. Then we can subtract our health minus the incoming damage. And then we can now set our new health to that. So our health minus the damage, we can get our health variable and set it for the authority. So plug in the authority like so. Before we plug this in, we need to clamp this because we don't want to go into the negatives. So we're going to drag off here and do a clamp float. So clamp float. The minimum will be 0. The maximum value will be 100. And we'll return that for our health. We just want to make sure that our health can't go below 0. So now that we're setting our health, we need to go ahead and update the widget, meaning we need to update our main HUD. So go to your core widgets main HUD. We need to update this health bar. So we need to call a interface event in our controller that will update or call an event in our main HUD to update the health bar. So we're going to go to our blueprints interfaces, and we should have our BPI prop hunt controller interface. So let's double click and open this up. We'll need to add a new function or event inside of here. So we're going to click the add icon right here and add a new function. And this will be called update health widget. And we'll have a input and change this to a float. And this will be our health. This will be our new health variable. We'll compile and save that. And now if we head over to our prop character, we want to call that interface. So we want to get the controller that is controlling this prop character. So if we right click, we can use the node get controller. So pawn get controller. Now we have a reference to the controller that is controlling this prop character. And therefore we can call the update health widget blueprint interface. So hook this up like so. And for our health, we want to plug in our health variable like so. So now all that is left to do is set up this interface event in our controller blueprints. Let's go to our blueprints and open up our PC prop hunt controller. So over here on the graph, we need to just implement our interface over here. So we have our update health widget. Double click on that. That will add that blueprint interface event. We're going to drag it up here. The same exact thing that we did over here to access our widget, we'll need to do when we update our health bar. So we'll need to add a custom event that will run on the client in order to reference our main HUD widget. So we're going to right click and add custom event. This will be called update health on client. And we'll need to set this from replicates not replicated to a run on only client. We'll also need to add one input and change this from a Boolean to a float. And we'll rename this to health. So compile and save that. Now up here, we can call the update health on client event that we just created and plug in our health like so. Then lastly, we can get our main HUD reference. And down here, what we'll need to do is add another event in our main HUD reference that we can call over here. So compile and save this. Let's go to our main HUD, and we'll need to head over to the graph. And in the graph, we'll go ahead and right click and add custom event. This will be called update health bar. And we'll just need to have one input and have this be a float and rename this to health. So to update our health bar, we just need to get our health bar variable, put that on the graph, and do a set percent. So we have this progress set percent. And for the percentage, we're going to take our health value and multiply this, operator multiply this value by 0.01, and plug that in for the in percent. So essentially, the health, which is a value of 0 to 100, needs to be converted to a percent, which this percent value is a value of 0 to 1. So we're just multiplying, shifting over the decimal point so that we can set the percentage of the health bar. So compile and save, and now we should be able to call this update health bar event from inside our controller. So off of our main HUD reference, we can call that update health bar event, and we can plug in the execution and our input for our health variable. So now what we should do is we should be able to test this out. So to recap, what we added is we added in our character the apply damage event for when we shoot a prop character, and then we set up the receive damage. So essentially, if we have any damage applied to this prop character, this event, any damage will get called. We're going to take the health, which is 100 by default, subtract it by the incoming damage. We're going to clamp that value. Minimum is 0, maximum will be 100. Set our new health and update the health widget. We'll call this interface on our player controller. So in our prop hunt controller, we're going to update health on client, call this client event, which then we call this event inside of our main HUD to update the health, which all that does is set the percentage of our health bar. So now let's go ahead and hit play. And so once it's selected the prop, we can shoot the prop. And over there on the left, you can see the health bar of the prop decrease if I hit the prop. So if I shoot over here, you can see that the health bar is not decreasing because I'm not hitting the prop. But if I shoot at the prop, you can see the health decrease all the way down to 0. So we know that our health bar is actually working, and we know that we're applying damage to the prop itself. The prop is actually taking damage if we shoot at it, if we actually hit the prop. So that is our apply damage and health bar for our prop character. The next thing that we'll need to add is when our prop character, when the health reaches 0, we need to add a win or lose screen. So essentially what we'll need to add is we're going to add a timer, a countdown timer. So when the game starts, the prop will have about 5 minutes for it to survive, and the hunters will have about 5 minutes for them to find the prop before the time is up. So if the prop hunters cannot find the prop within the given time, the prop character wins. However, if the prop hunters find the prop and successfully kill the prop character by shooting at it, and its health reaches 0, then the hunters win. So we need to set up this win and lose logic so that someone can actually win the game. So the first thing that we'll do to set this up is we're going to set up a win or lose screen. on our widget so that we can see if we actually win the game or if we actually lose the game. So we're going to go to our main HUD and go over to the designer, and onto our canvas panel, we want to search for a background blur. So we have this background blur. We can take this widget and drag it onto our canvas panel like so. Then we want to select this background blur, set this to a variable, and rename this to our win screen. We're going to take this win screen and anchor this all the way around. So we're going to choose this bottom right anchor right here. That should set our anchor to the entire screen. And then we're going to reset our offset to 0, 0, or offset right to 0, 0. So we should have 0, 0. It should fill the entire screen like this. Then we want to change the Z order. So the Z order is sort of like bringing this widget to the front. So the higher this number is, if I set this to 2, the more in front this will be in front of the other different widget objects on our screen. Now what the background blur does, what this widget does, is down here under the appearance, we can change things like the blur strength. So if I increase this to 30, you can see that it blurs out anything behind it. So compile and save that. So basically we can sort of use this as the win screen. We can put some text in the center here. You can say, you won, and there's a new game that is starting soon. So onto this background blur, we'll need to add some text. That way we can say whether or not the player won and that there's a new game that is starting soon. So onto this, we want to search for first a vertical box. We have this vertical box. We can drag and drop it onto the win screen, or onto this background blur. And with the vertical box selected, we're going to set the alignment. So if you select the vertical box, we can set the alignment to center align horizontally and center align vertically. So it should be this little box, green box here in the center of our screen. And then in our palette, we want to search for some text. Search for text. We should have our normal text. So take that text and drag it onto our vertical box. And now we can select this text and actually rename this. So first things first, we want to set this to a variable. And we're going to rename this to our win screen text. That will be our win screen text. And then we want to go ahead and change the text itself. So we'll change this to you win exclamation mark. And we'll change the font size as well. We'll scale this up to 60. And then lastly, we want to set the justification to align text center. Compile and save that. The next thing that we'll add is another text onto that vertical box. So it should be directly below the you win text. And select that text. And we're just going to rename the content to new game starting soon, ... And also we're going to set this to align text center. We could also change the font of this text to 33. So it's just a little bit larger. We'll just compile and save that. So now we have our win screen, but as you may know, this is showing on our screen by default. So what we'll need to do is set that to hidden by default. So select your win screen background blur. And in the details, we want to scroll down until we see visibility. We want to change this to hidden by default and compile and save that. Also, we can hide it from our main HUD over here by clicking this eyeball icon. That will toggle the visibility of that widget on our designer graph over here. So by default, that win screen will be hidden from the player's screen so that later on we can show it when either the player wins or loses the game. So let's go ahead and add the winning and losing logic for our prop hunt game. So if we go to our prop character, over here is where we set up our health, receive health, or event any damage. We'll need to add a comment for this. So let's select this and press C to add a comment. And we'll just rename this to receive damage and set that to show bubble when zoomed. So essentially this is the event when we receive any damage And then over here, we call this update health widget. So we want to do one extra check right here at the very end. And essentially that check is we want to check and see if our health has reached 0. It has the prop character's health reach 0, because if so, then we want to end the game because the prop character has been essentially killed or found by the hunters. So we're going to do a little check over here at the very end. So whenever we receive any damage, we want to get our health variable. We want to check and see if our health is less than or equal to 0. So if it is less than or equal to 0, we'll do a branch. And if it is, we want to call basically an event that will end the game, because that means that our prop character, the health has reached 0, which means that the hunters have successfully found the prop character. So the way that will end the game is we'll need to add an event or an interface for our game mode that will be called in the game mode, which will end the game and show the win or lose screen for all of the players who are connected to the server. So we need to go to our core blueprints folder and interfaces, and we'll need to add a new interface for our game mode blueprint. So that way we can communicate from our prop character to our game mode blueprint. So we'll need to right click and create a new blueprint. And under the blueprint, we want to choose the blueprint interface. We're going to rename this to our BPI underscore prop hunt game mode. This is our BPI prop hunt game mode interface. And just double click and open this up. And this will have one function. So just rename the function in here to end the game. It'll be called end the game. And we want to have this have one input of the type Boolean. And for the input, this will be essentially whether or not the prop won. This will be called prop1 ? And compile and save. So now we need to add this interface to our game mode. So let's close out of there and go to our blueprints, open up our game mode, prop hunt game mode. And if we head over to the class settings, click on class settings, under our interfaces, we can add or implement our interface. We can click this add button and search for our BPI underscore. We want to add the prop hunt game mode. So select that and ensure that that is the prop hunt game mode, and compile and save that once you've added it. So now that we've added that game mode interface, under the interfaces, we should have that end of the game interface event. So to implement it, we just double click on that interface event and it should add it to our graph. So now we have an event for when the game will end. And essentially we can go ahead and check and see whether or not the prop character has won. So off of our prop 1, what we're going to do is take this and promote this to a variable. And we're just going to leave that as prop 1. And then for each character that has joined the game or is currently connected to the server, we want to get our players array and do a for each loop. So we'll do a for each loop. So for each player, we want to go ahead and update and call an interface on their controller to show the win screen widget. So what we'll do is we're going to get all the players and check and see if the reference is valid. So we'll do a is valid check. And then what we want to do is we want to call an interface on our player controller that will show the win screen widget. So we'll need to go ahead and go to our interfaces and open up our BPI prop hunt controller interface. And we'll need to add a new interface function for our win screen widget to show it. So this will be called our show win screen widget. This will have one single input. So select it and add one input of the type Boolean and just rename this to prop1 ? And compile and save. Because we want to know if the prop won or lost the game, and that will determine whether or not the hunters or the prop character won. Now go back to your game mode, your prop hunt game mode, and off of this array element, we can call that interface message our show win screen widget message. So we just hook this up for the is valid, and whether or not the prop won, we're getting that variable over here. So we can just plug in our prop1 Boolean up here like so. So essentially all that we're doing is when this event end game gets called, we're saving whether or not the prop won the game. And then for each player on the server, we're going to show the win screen widget and show whether or not the prop won or not. So first things first, we actually need to call this event end game from inside our prop character. So basically, if the prop character is dead, if its health reaches 0, we want to right click and get game mode, get our game mode, our current game mode, and we can call that interface our end game message interface message. So hook this up for the true. And then whether or not the prop won or not, this will actually be set to false because our prop character's health reaches 0, meaning that the prop character was found by the hunters. Thus, this Boolean will be false, meaning the prop did not win. So compile and save that. So now when the prop character's health reaches 0, we'll call this interface end the game on our game mode, which will save whether or not the prop won. In our case, the prop lost the game. So for each player, we're going to call this show win screen widget interface event in our controller. So let's go to our controller to set up that interface event. So under our interfaces, we should have that show win screen widget interface. We'll just double click and add it onto the graph. And what we'll need to do is add a custom event. Right click, add custom event. That will run on the client. So we'll name this show win screen on client. And we'll set this to a run on owning client and compile and save. And we'll actually need to have 2 inputs for this. And each of these will need to be set to a Boolean. For the first input, this will be whether or not the prop won, question mark. And then the second input will be if we are the prop. So this will be called is prop, question mark, and compile and save that. Now we need to know whether or not the prop won. So we're going to call this show win screen on client. And we'll plug in whether or not the prop won. Now for this is prop, we want to know if this player controller or if this character is the prop, because that will determine whether or not we should show that they lost or that the hunters won. The way that we'll do that is we're going to, over here when we set up the prop widget, we're going to keep track if we are the prop or not the prop. Because we get this variable, this Boolean variable, whether or not we are the prop or if we are not the prop. The way that we can do this is if we simply move this node over, we can take this is prop and promote this to a variable and compile and save that and just hook this up for the execution. So now we're saving a variable to whether or not we are the prop character. So compile and save that. And now we just plug in the is prop variable into this is prop input right here. So then lastly, all we need to do is get our main HUD reference, and we'll need to call an event inside of that main HUD to update and show our win screen. So let's go to our main HUD and head over to the graph. And in here, we'll need to right click and add a custom event. And we'll name this to show win screen. And this will have the same inputs. So we'll need to have 2 Boolean inputs. The first one will be called prop won, question mark. And the second one will be called is prop, question mark. So compile and save that. And let's go ahead and make sure that we call this event first. So let's go back to our controller. And then off our main HUD reference, we can call that show win screen function event. Plug in the execution and both the inputs. We'll compile and save. Now let's head back to our main HUD and actually set up the event. So for our show win screen event, first thing that we need to do is set the visibility of our win screen. So over here on the left, we have our win screen as a variable. We can go ahead and get that widget on the graph and first do a set of visibility to set the visibility of this widget to be visible. The next thing that we'll need to do is we want to set the win screen text to either you won the game because you found the prop, or you lost the game because the prop hunters found you. So we're going to get our win screen text, get that on the graph, and do a set text. We're going to choose the widget set text down here at the bottom and hook up the execution. And for this in text, we're going to do a select. So we'll do a select, and we're going to use this select down here at the very bottom. So it says we have option 0 or option 1. We have an index. So for our index, we want to plug in whether or not the prop won. We're going to take our prop 1 boolean and plug that in for the index. Now we have this true or false selection. And then what we want to do is even further, we want to take off of the false. We want to do a select, do another select, and plug this in for if we are the prop. So if we are the prop, we'll plug that in for the index. Now we'll have again another true or false selection. So if we are not the prop, but if we won, this text will be called "you won!" exclamation mark, "you found the prop!" exclamation mark. However, if we are the prop, but if we lost, this text will be called "you lost!" exclamation mark, "prop hunters win!" exclamation mark. File and save. Again, off of this true, we'll do another select. So we'll use the select down here at the bottom and plug this in for the is prop. That will give us a true and false. For the false, we're going to name this to "you lost!" exclamation mark, "the prop won!" exclamation mark. So this is if the prop won and if we are not the prop. Now, if the prop won and if we are the prop, that means that we can name this to "you won!" exclamation mark, "you survived the hunters!" exclamation mark. So just compile and save that. So this will just update the win screen text to whether or not we survived the hunters, or if we are the prop and we won the game, or if we are the hunters and we won the game. That will just update the win screen text. Last thing that I want to do, which is completely visual, is I just want to update the text color. If we won the game, we'll set that to green. If we lost the game, we'll set the text to red. So what we'll do is off of this win screen text, we can do a set color and opacity. We have appearance, set color, and opacity. And hook up the execution. And for our in color and opacity, we can do a select. And for our index over here, all we need to do is plug in whether or not the prop won for our index, and that will give us a true and false. And then off of our false, we'll do a select. And also off of our true, we'll do another select. And so for these indexes, we'll plug in the other variable is prop for our index, is prop for our index right here. And then whether or not we are the prop, we're going to plug in a color that we are going to set the text to. So off of our false, we'll first do a make slate color. So we can choose a specific color. So I'm going to set this to a red color. So this will be if we lost. And then we can copy and paste this again and set this color to a green color if we won. So we're going to hook up this slate color for the true and also for the false on this select. So we have true and false. And for our red color, this will be set up to the false and the true on this select. So essentially, if the following conditions are met, if they win the game, we should see the green color. If we lost the game, the text should be this red color. Let's compile and save, and let's actually add a comment for this. This will be our show win screen widget, just so we know that this is our show win screen logic. So essentially, all that we're doing in here is we're setting the visibility of our win screen to visible. That way we can see it on the screen. We're updating the text, the win screen text, so whether or not we won the game or lost it, and then we're setting the color of that text. So now we should be able to test all this out because we, in the prop characters, set up the end game interface that gets called on the game mode, which basically loops for all the players and shows the win screen whether or not we won or lost the game. Let's go ahead and hit play and wait for our game mode to select the prop character. So I am the prop character. We'll need to go over to this character and shoot the prop character. Apply some damage. And now that it hits 0, you can see that you won. You found the prop. And over there on the right, it says you lost. The prop hunters win. Now it looks like we actually messed up our color selection. So this actually says red. Should be the other way around. This should be the green text. You won. This text on the left should be red. You lost. But let's just really quickly update and fix that. Go back to your main HUD widget. You just need to swap the colors around. So let's unhook both of these. Should have the red on the top. So we'll plug this in for the true over here, and this will be the false over here. And for the green, this will be the false and the true down here. So compile and save. Now let's test this out. Hit play. We'll wait for our game mode to select the prop character. Then we'll go ahead and shoot the characters. Apply some damage. Now you can see we won, we found the prop. And on the other side, you can see you lost. The prop hunters win. Okay, it also says new game starting soon, but we'll need to set up that logic for setting up the next game. But as you can see, we set up the win or lose screen based on if the prop character's health reaches 0, meaning if the prop hunters have found the prop. So the next thing that we'll need to add is in our game mode. We need to go to our game mode. What we need to do is we need to add the logic for starting our next game, but also we need to add a timer. Because let's say that the prop character is really good at hiding, and they end up making it to the end of the game hiding, and none of the prop hunters actually found the character. So essentially, if that happens, we need to have a timer and give the hunters a certain amount of time to find the prop before the game ends and we declare a winner or loser. So to add that countdown timer, I'm actually going to move our end game logic down here, but right directly above it, we're going to add an event. So right click and add custom event. We're going to name this to start game loop timer. This will start the game countdown timer. And to set a timer, we're going to use the set timer by event node. So this will start a countdown timer. And so we're going to set a time. So this will specify how many seconds should we have before this countdowns. So we're going to set this to 300 seconds. So that's roughly 5 minutes. And then we're going to take the return value and we're going to promote this to a variable because we need a reference to our game loop timer. So compile and save that. So this game loop timer will start timer. And so after 300 seconds is up, we need to call an event. So drag off this event and add a custom event that will get called. This will be called end game. So after 5 minutes, it will call this end game event, which we just need to call this interface down here, the event end game. So we can actually just off of here call our end the game. So we can call this function end the game, which will call this event down here. And since the time is up, meaning that the hunters have not found the prop within 5 minutes, we're going to declare that the prop has won. So we're going to leave this checkbox as set to true. So compile and save that. So now we just need to call this timer or start the timer when the game starts. So I'm going to call this event the start game loop timer. Over here, we scroll out. We have this for each loop. So for each player, after we update and set up the prop widget off this completed, we're going to call that start game loop timer. Basically, after we select a prop character, we set up all the widgets. We're going to call our start game loop timer. which will start the countdown for 5 minutes. And when that 5 minutes is up, we're going to check and see if the prop character is still alive, in which case they are. We're going to declare that the prop character has won the game. Now, the other thing I want to do is if, for whatever reason, our prop character has died, we want to clear this timer, because if this event end, the game gets called, and if the prop character loses, we want to stop this timer from counting down because we already have a winner or loser. So we're going to take this logic and move this over and simply get a reference to our game loop timer and just call the clear and invalidate timer by handle. So this will just ensure that if the hunters find the prop character and successfully kill the prop character, we're going to stop this timer because that means that the hunters have won. So now we have our simple countdown timer, and this will actually happen in the background. Right now we don't have any visual on our screen. We don't know that the game is counting down at all. And so what we'll need to add is an actual countdown widget so we can see how much time is remaining before we need to show that the prop character has won. And if we actually wanted to test that logic out, we could actually give this a time of, say, 10 seconds. So compile, save, let's hit play. So after it selects the prop, let's give the game about 10 seconds before it declares a winner. But usually this will be set to about 5 minutes. So as you can see, the hunter has lost. You lost, the prop won. While over here, the prop character has won because the time has run out and we have survived the hunters. So as you can see, our win and lose logic is working properly. And we can actually reset this to our 300 seconds. Compile and save that. Now what we want to do is we want to add that countdown timer so that we can actually visualize the time remaining on our screen. So the way that we'll implement that is in our main HUD widget. You want to go to your main HUD and go over to the designer, and we're going to add a little timer at the top right of our screen. That will just visualize how much time is remaining, how much time do we have left. So in our main HUD, we're going to first add a border. We'll search for a border. We're going to drag and drop it onto our canvas panel. And we'll need to anchor this in the top right, like so. And we'll just resize this to be something like this. I'm going to change the color and opacity. Actually, we need to change the brush color. So down here in the brush color, we need to expand this. And under the brush, I actually want to set the tint. So brush tint, we're going to change this to a black color. And alpha, we're going to set this to 0.5. Something like this. It's a little transparent. Compile and save that. Then onto this border, we want to add a horizontal box onto this border widget. And then in that horizontal box, we want to add an image as well as a text. So first things first, we're going to add actually a size box. We have the size box widget. We can add that into the horizontal box. And then with that size box selected, what we can do is we can set a size. So in the child layout here, we can set a width and height override. I'm going to set this to 80 by 80 pixels. It'll be roughly 80 by 80 pixels. Let's take this border and make sure that it is sized properly, something like this. And then inside of that size box, we want to search for an image and drag and drop it into the size box. And for this image, we'll need to import a texture. So head to your core widgets, textures. And we should have this timer icon as well in our project files miscellaneous. So take that timer icon and import it right in our widgets textures folder. And we'll just need to double click and open this up and set this to the texture group from world to UI so that the engine knows that this is used for user interface. Close out of there. And now that we have that texture imported, we can go back to our main HUD, select this image, and under the image, we can set that to our timer icon. Okay, so something like that. Then inside of this horizontal box, we can add a text. Search for a text. And just drag and drop that text inside the horizontal box like so. And so this text, we'll need to go ahead and set this to a variable and rename this to our timer text. What we'll also do is we'll fill horizontally and set the alignment to center align vertically like this. And then we'll go ahead and rename the text to 5 minutes. So we'll also set this size to 45, the font size, and that should be all set. So compile and save that. So now we have our timer text set up. That will be shown on our screen. The last thing that we need to do is actually set up the functionality for this timer text to actually start counting down and updating as the game is started. So let's head over to the graph, and right below our show windscreen logic, we're going to add an event for starting our timer. So down here, we're going to add custom event, and this will be called the start timer. Just compile and save that. So what we'll do is we're going to, off the start timer, do a set timer by event. And so for our event, we'll drag off here and do a add custom event. And this can just be named end timer. File and save that. Now for our time, we're going to set this as the same duration as what we set up in our game mode. So in our prop hunt game mode, we gave our game loop timer a time of 300 seconds. So in our main HUD, we're going to give this start timer the same duration of 300 seconds. Then we're going to save a reference to that timer. So off of this countdown timer, we're going to promote that to a variable, and we'll rename this to our countdown timer. So compile and save that. Now that we have this countdown timer, all we need to do is get the time remaining from this timer, and every second update the timer text. So every second to update that text, we're going to do another timer. So off of here, we'll do another set timer by event. And for this event, we'll go ahead and add custom event. This will be called update timer text. So we'll update the timer text. So we'll set this to every 1 second, set that to looping. So every 1 second, we're going to get our countdown timer. So we're going to get our countdown timer and get timer remaining time by handle. And that will return how much time is remaining. So off of that, we'll need to actually get the from seconds, get the seconds. Then from there, we'll need to get that as a time span. This will return the actual time that is remaining in this countdown timer. So every second, we're going to get that time remaining and update our timer text. So we should have our timer text as a variable over here. We can just get that on the graph and call the set text. We have this widget set text function. All we need to do is hook up the execution. And for our in text, we just plug in the time span. So compile and save. So to recap what we're doing, we're going to call this start timer event. When that gets called, we're going to start our countdown timer of 300 seconds, which is 5 minutes. And then we're going to start another timer, which every second will loop. We'll check our countdown timer, get the time remaining, and update the timer text to showcase the time that we have left. So all that is left to do is to call this start timer event when the game is started. So to call this event, we'll do it in our player controller. So let's actually head over to our PC prop hunt controller. We'll need to add an interface as well as a custom event. So first, let's add an interface. Let's go to our blueprints, interfaces, and open up our prop hunt controller. And in here, we'll add a new blueprint function interface and rename this to start countdown widget. And we don't need to have any inputs. It'll just be an event. We'll just save it like so. Then go back to our player controller. We should have that new interface, start countdown widget. Just double click on that to add that event on our graph. And then we'll just need to right click and add a custom event. It will be called on the client. So this will be called start countdown on client. And we'll set this to a run on owning client like so. So we'll call that start countdown on client of our interface. Then lastly, we'll just get our main HUD reference and call that event that we set up, which is called start timer. And just hook that up like so. So compile and save that. So now in our game mode, we can call this interface event when the game has started. So off of our prop hunt game mode, we already have a for each loop, which will get called. So for each of the players, we're calling this setup prop widget. So in addition to that, what we can do is actually right after our is valid check, if this controller is valid, what we'll do is we'll call our start countdown widget message. So for each player on the server, we'll start the countdown widget, because basically we're going to start the game loop timer as well. So compile and save. So now that start countdown widget interface will be called on the controller, which will be called on the client. We'll start the timer in our main HUD, which will start the timer and start updating the time remaining text right here. So now let's go ahead and hit play. So right now it says waiting for more players. The timer hasn't started. It's set to 5 minutes. But as soon as the game starts, you can see that the time is starting to tick down. We have 4 minutes and 54 seconds before the game ends. So that is our countdown timer. We know that the countdown will work. And after the time is up, if the prop is successfully hidden from the character and they haven't killed it, they haven't reduced its health to 0, that means that the prop character has won and the hunters have lost. So we set up our countdown timer. The last thing that we'll need to set up is a way for the game to reset after the win or lose logic. So essentially, after our win and lose screen, we need to set up a reset so that it will reset the game and start a new game. So to do that, we want to head over to the game mode and right off this event end game. After we show the win screen widget off of the completed, what we can do is we can do a set timer by event. So we can start a countdown timer. And we can give this timer about 10 seconds before we start another game. Before the event that gets called, we can add a custom event. And we can just rename this to start next game. Basically, we'll start our next game. So after this end game gets called, we're going to set a timer for 10 seconds and we'll start the next game. So for our start next game logic, all that we're going to do is reopen this map that we have open here so that all the logic and the game mode will be reset and it will select a new player to be as the prop character. So to reset the map and reopen the level, we're going to use the node execute console command. And in here, we're going to type in the following argument: server travel space third person map. So essentially what this does is, what server travel does is it will take all the players in the server and travel them to this map that we specify. So if we specify the same map that we have open here, essentially what it will do is it will reopen the map and all the players will join that map that we opened. And so it will essentially reset the map and it will be a brand new game mode where the game hasn't started yet, and we'll run through our event post login, our start game. All of our game logic will be reset. So we could actually test this out. So what we're going to do is let's hit play. Let's go ahead and wait for the server to select the prop character. Let's go ahead and shoot the prop character. So it says you won, you found the prop, and you lost, the prop hunters won. So we're going to give it about 10 seconds before it starts the next game. Go ahead and just wait. And as you can see, it reopened the map, respawned in both as the soldiers. And now you can see that it reset the game. I have been selected as the prop character. So a different player has been selected. And we have that countdown timer ticking down as well. So that is our basic game loop. And we also set up our reset game logic, where we reopen the map and reset the game mode and everything. Now, the last thing that I want to add to our project is I want to add just a nice little visual for our prop hunters. So what you'll notice is when you fire your rifle on the ground, there really is no indication whether or not you hit the actual prop character. So what I want to add is when I shoot the prop character, I want to add a little hit marker that will notify the hunter that we have hit the prop. Okay, because right now if I shoot this barrel or this crate, we don't know if this is the prop or not. There's no visual indication for us. So I want to add a crosshair hit marker effect. That way the player knows that they have found the prop and we can continue to shoot at it. So the way that we're going to add that is through our main HUD. So open up your widget main HUD. And in here, we're going to take our crosshair, which is this image 0. And actually, let's go ahead and rename this to our crosshair. Compile and save. And let's copy and paste this again. So we should have 2 of them. And we're going to take this other one and just rename this to our hit marker. We should have one that says crosshair and one that says hit marker. Now this one that says hit marker, we want to center this in the middle. So set the position X to 0 and position Y to 0. But we want to rotate it a little bit. So you can see it's perfectly lined up with the other one. So this hit marker, we want to go down here to the render transform and expand the transform. We want to, under the angle, rotate this like so. We'll give it an angle about 45 degrees. So it should look like this. Then all we have to do is we want to give this a tint. So under the tint, we can change this to a red tint. And now we have this hit effect. So compile and save that. So all we have to do is set the visibility of this hit marker to visible or hidden, whether or not we actually hit the prop character. Okay, and that will give the hunter an indication whether or not we actually hit something. So by default, we want to select this hit marker and actually set the visibility, set the hidden. That way it's not shown on the screen. And then what we want to add is we want to add a animation, a simple widget animation that will scale this up. So it'll give us sort of like a pop effect. It'll also fade away. So to animate any of our widgets, we actually have a section down here, a little tab that will pop open for animation. So you can animate any type of user interface or widget to create some, fancy user interface. So in our case, we want to select the hit marker image and open the animations tab by clicking animations. And with that selected, we can add a new animation and name this to our hit prop anim, hit prop animation. Want to go ahead and select that. And with that selected, we can add a new animation for our hit marker. We have our hit marker right here. So with our hit marker selected, we can add a track for different types of things. We can change the color, we can change the visibility. Now in our case, what we want to change is the transform. So select transform. And if we expand the transform, we have the keys for translation, rotation, and scale. Really all that we're going to mess around with is the scale. And I zoom up here and reopen my animations. I'm going to move our little timeline over here to about 0.15 seconds. So 0.15 seconds. I'm going to set the scale to 1.5 on the X and 1.5 on the Y. What that should add are these little dots on our timeline, which are keys. And then we want to take this and move this to about 0.30 seconds. And we're going to reset the scale back to 1 on the X and 1 on the Y. So what it should add are these keys. As you can see, as I scrub our timeline, you can see the sort of the effect of the scaling. So at 0.15 seconds, that scales up. At 0.3 seconds, that scales all the way back down. We have sort of this hit effect. Now, what we also want to add is sort of a fade out. So what we'll do is at 0.03 seconds, we're going to add another track. So select your hit marker and add a track for render opacity. So now if we unexpand our transform, we should see just our render opacity track. And so at point 30 seconds, we add a keyframe for visible. And then we can move this all the way over here to about 0.90 seconds and set our render opacity value to 0. But what that should do is it'll give us this fade out. You can see if we put our cursor all the way back to 0 and press play, we have sort of this hit effect and fade out. So it scales up and fades out. So this is what the animation will look like, and we can play by pressing the spacebar to preview what it'll look like. So compile and save that. We have our simple hit animation. And to unselect the animation, you can just select anywhere off of this animation, and that will get us out of the animation mode. But now that we've created that animation, we can add it in the graph. So head over to our graph. And so over here on our main HUD graph, we'll need to add an event for playing our hit animation. So down here below our timer, we can actually add a comment for our timer. This will be our start countdown timer. Well, right below it, we can right click and add a custom event, which will be called our play hit animation. Compile and save. So we should be able to get a reference to our hit marker. So we have our hit marker. The first thing that we want to do is we want to get our hit marker image and set the visibility of this widget to visible. And then what we'll do is we'll play the animation. So we should have a new animation. So under the variables, we have this animations. You just need to expand it like so. Down below, we have this hit prop anim. We can take that animation, get it on the graph, and off of there call our play animation node. So play animation. Let's hook up the execution. The in animation is our hit prop animation. Play this once. And once it's complete, we want to go ahead and hide the widget again. The way that we'll check and see whether or not the animation is done playing is off of this hit prop anim, we can call a bind animation finished. So basically we can bind an event to when this animation has finished being played on the screen. So off of this delegate, we can drag up here and do a add custom event. And we can just rename this custom event to hide widget. So compile and save. And then off of this event, all we have to do is get our hit marker widget and set the visibility back to hidden. So compile and save that. And now we have our simple hit marker set up. So basically when we hit the prop character, when we shoot it, we'll just call this play hit animation, set the visibility to visible, play our hit animation, and when it's finished playing, we'll set it back to hidden. Now we just need to add an event or interface that will get called in our player controller whenever we shoot and hit the prop character. So in our PC prop hunt controller, I actually need to first add the interface event. So let's go to our interfaces and open up our prop hunt controller. And we'll need to add a new blueprint function here and name this to play crosshair hit for our hit effects. And just compile and save that. And then in our PC prop hunt controller, we can add that interface event, play crosshair hit. And we can add a custom event, add custom event. We can name this to show crosshair on client. We'll set this to a run on owning client, compile and save. And off of that interface, we can call that event, show crosshair hit on client. Then lastly, we can get our main HUD reference and call the play hit animation event. So now all that is left to do is to call this interface from inside our third-person character. So when we fire our rifle, if we actually hit the prop character, we can call this play crosshair hit interface from inside our character. Let's go and find our blueprints folder and open up our third-person character. And you want to go to your fire rifle fire line trace function. So in here, we already have a check to see if we have hit the actor, which is our prop. So if we hit the actor, and if that actor has the tag prop, meaning if it is the prop character, we can then call that interface the hit show crosshair hit interface. So we can show that we hit the prop character. So we'll right click and get controller. We'll call the pawn get controller node. And from there, we can call our interface the crosshair play crosshair hit message interface. We'll just hook this up like so. So compile and save. Now we should be able to test this out. So let's go back to our game and hit play. Let's wait for our game mode to select the prop character. And so now that it has been selected, I can shoot at it. And you can see that if I shoot over here, there's no hit marker, but if I shoot the prop, it will play the hit marker like so. So that is our simple hit marker effect.